That was insane.
Welcome back. I'm gonna do a Buster song, right? So let's get Buster going.
I'm not sure we've got a show that would work very well because most of it was shouting, to be honest. Some of it my shouting, I admit.
Yeah. So I think you did all of the shouting, didn't you?
Actually, I did. Yeah.
Good day, everybody. Welcome to our Saturday morning discussion.
The definition you've given of level is as a horizontal plane. So by this definition, level is horizontal. Oh wow! Okay, the Earth is the Earth. I agree with that.
Excellent.
Level is horizontal as I defined. I agree with that. So is it rational to believe both? Yes, we're done. Oh wow!
I got your numbers right here.
You interrupted me.
It's just as easy as 1, 2, 3.
You interrupted me there. I was speaking.
You have to open your mind.
But it's painful.
Imagination is all you need. Don't take advice from fools.
Okay.
Everything that they say is in vain.
You interrupted me again.
Never take advice from fools. We all know what they do is in vain.
There are many definitions in the dictionary, some of them contradictory. Scientific definitions often disagree with commonly used ones, and indeed the dictionary ones. So, and level is horizontal by definition, and you would be insane. You would be insane to deny it. Okay, the Earth is the Earth. I agree with that. It's horizontal as I defined. I agree with that. So, is it rational to believe both? Yes, we're done. Oh wow!
Everything is relative to you.
Under the definition that I accept, a level surface is not a plane surface.
Just like those straight lines are curving.
Mike, I'm happy to go with that definition for now.
Drive down the road, don't you ever swerve. And I don't know.
Shaped like a ball, that'll do. Yeah, is the Earth shaped like a ball?
Where all of this goes. Never take advice from fools.
Oh wow!
Everything that they say is in vain.
All verticals are parallel.
Never take advice from fools. Everything that they do is
It's been wonderful chatting with you, Betty. I can't believe, so we've now tackled, it's not possible for two people to be below each other, and level is definitely horizontal, and the Earth is definitely the Earth.
Oh wow!
Thank you.
Yeah, we've agreed there. Yeah, the surveying definition says level is the same as horizontal.
We've been talking about the real globe for a long time here.
I know the game that you're playing.
It's the dogmatic globe.
And I know exactly what's on your mind.
Dogmatic globe.
You got your playbook, it's alright.
Yeah, I'm sort of losing here, Mike.
Your model dictates what you will find.
I'm actually trying to help you. I'm trying to help you.
I don't know
Thank you for helping me, but
where all of this goes.
yeah, I'm sort of losing here, Mike.
Don't take advice from fools.
No, let me finish.
Everything that they say is in vain.
Mike, you interrupted again.
Never take advice from fools.
This is the dogmatic globe.
We all know what they do is in vain.
Under the definition that I accept, a level surface is not a plane surface.
So you think it's a synthetic proposition that could be proven experimentally?
That the Earth is a globe? Yeah, I mean,
Yeah.
either the Earth is a globe or it's not a globe.
Good day, everybody. Welcome to our Saturday morning discussion.
And we are live. This is the show. That last one was just a quick debate for the debate series. I don't know whether you could call it a debate. Did he have anything? Like, did he come with anything? What was his argument? Just a nuh-uh.
No, 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 no.
You can't define vertical and horizontal because you'll change it in the end or something. I don't know. I haven't got a clue what that was.
Well, it was supposed to be a proof for proof, wasn't it? That's
I
how it
think
was
so,
built.
yeah.
Yeah, I don't remember hearing any proofs that he brought. I mean, you definitely did show what you consider to be a
Attempted.
proof. Yeah.
He
Does
wouldn't
anybody?
let me
Maybe
do
I'm
it,
wrong.
right? Yeah, that was
Right,
the
he wouldn't let you do it.
extension of the Vesica Pisces using the 2 points that you generate from making a Vesica Pisces.
which you didn't
Extends
know
the
what it was.
perpendiculars like to
Yeah, he did not
infinity.
know. Yeah, he did not know what a Vesica Pisces was.
No,
No.
no. So he
He
doesn't
also,
really
he also
understand geometric perpendicular.
he also claimed to have used a water level tool, but didn't know that if you extend one end of the water level tool, doesn't matter where you go, as long as the water doesn't come spilling out or anything else, it is still a straight line.
Yeah,
Still
and
didn't seem
A
to
won't
understand that.
move, right? If you don't
Correct.
move the header tank, it won't change its level. Like,
Yep.
it remains A no matter where you move B to. It's the whole point. He didn't
Yep.
seem to realise that we've got a realising Euclid test. I mean, obviously, it's difficult to talk to people about these sort of things because they get too triggered, and it's difficult for them to say things. He had to have it go lower. The further you move away, the lower you go. Jesse Kozlowski's taught him that. And then done a Jesse Kozlowski. Nobody knows why. It's just.
And his
Go on, sorry.
I'm sorry, his proof, quote unquote proof, was what, the picture of Toronto? Was that meant to be his proof? I'm looking for a
I think
proof
so.
that
He
he
brought
might
some
have.
pictures. Yeah.
Okay.
He did seem to say that some sort of emphatic. He claimed a victory because that's what level would have to do to match his mind model. Yeah, hump. Don't know whether he's aware because that's old school, right?
Definitely.
Like right back from when we first came into this, and I said to people, like, what do you imagine? Most people do. Obviously, first thing, you have A to B, it's horizontal, you know it is, but then there's a model creeps in. And then that tells you, well, it can't be that. I don't know why. For some reason, somebody's told them it can't be. I don't know why. It obviously is in reality. This is why the problems come in. So they have to put a hump in the middle. But then somebody comes along and tells them, no, there has to be a drop. Drop from horizontal, not a rise. But then if you have that, speaking logically, then your horizontal has to go up above the rise. You can't have your horizontal chopping through the water. So it's all imagined, and it's so weird to even imagine it that I don't know how normal people deal with it. I don't have a model, so to me, it's strange to imagine people imagining something different. But I'm guessing most people just don't even think about it. Which is where we come to Logic Night. Logic is the sort of natural thought, I call it. Natural reasoning that you do. Brings you to conclusions, which is obviously what the nth meme did to Rams. Mr. Ramsbottom. Sophist in the making, obviously. Wordsmith. Wanting you to stop the use of words. Allowing no further definitions for things. Assuming that a definition adding to a definition to further clarify it changes its meaning. That's a high-grade sophistry. Yeah,
All
Paige.
because I'm convinced he had the model to begin with. This is pretty obvious. There's no way to drop the model. It is all encompassing.
Yeah, I'd say it's almost getting a little bit it's strange because you see people gaslighting us. Obviously gaslighting, because I'm absolutely certain of that. I know the understanding of geometry and I know how it relates to reality. For them to just say, no, not that, with no understanding of it. I mean, we do have a test. It's called the Realizing Euclid test. It's basically a shared straight line segment, which is basically the same as what this is. This Vesica Pisces. But there's a bit of an easier way of doing it, obviously. But the Vesica Pisces is just an shared straight line, extending straight lines, a ratio 1.7, bigger every time. I don't know whether I actually got to show the logical progression. Do you want to go through that, Kev? Are you here? Have you got a bit of time now, Kev?
Yeah, yeah.
Do you want to go over the
Absolutely.
Okay, let me just get this back, bring this back to 2 points. Okay, I'll give you the screen back again.
Right.
Okay, now this is how easy it should be, rather than people like Rams messing about with this. Right, so you do have 2 points. That's what we were doing. That's why the thing about with Emma, right? It's the first thing that you can ever prove within anything I say. If you were wanting to be able to prove something to yourself, then this is where you start. This is Mathematics 101, and you're starting at the beginning. Straight line. Obviously, that which lies evenly between its extreme points doesn't really cut it. So you want the shortest distance between 2 points.
Yes.
Only way you can actually verify that, because you can measure it and make sure that you cannot get any shorter distance.
Yeah.
So
and can I just make a clarification? So, and these 2 points, this is without regard to anything around it. If you were actually doing this in reality, it's it's these 2 points without regard to anything else around it. Yeah.
yeah,
I.e.
just 2 points.
Right. I.e. the ground, the building over there, the guy standing over there. None of that matters. You're talking about point A and point B, and the relationship between these 2 points.
Yeah, and the way we can relate it to start off with to reality would be using a water level or some sort of level, 2 points, that you can say that they are at an equal elevation, right? You've got something else to relate them to in reality, right?
Right.
For this sake, you can say it's a line going from left to right across the page if you want, right? Like you just have 2 points, and you make a circle from using A to B as a radius, but then you also do the same from B back to A. So you just double up. So what you've now got, you've now got is 2 circles with a common straight line, shared straight line. This is the same radius.
Same radius. Yeah, same
within
radius.
two circles. So in this, you've also got the equal triangles, right? This is a radius as well, and this is also a
Equilateral
radius.
triangle.
So you've got your equilateral triangle. But because we're doing this, this is a what you call a compass only proof for the straight line. So we don't need a ruler for this. And then we get this point here because you've generated two more points here and here. Right, now every time you do this, you will generate two more points, and this just goes on forever, right? You're making another Vesica Pisces,
And those 2 points are that you just created and pointed to in the Vesica Pisces that are oriented here horizontally by my view, right?
yeah,
Those 2 points, are they an extension of point A and point that line
yeah,
that was then point A and point B?
yeah. So this point here is a straight line, and passing through point A and point B. You just extend the straight line
Right.
using the Vesica Pisces. So we've made another 2 points, so you can do this, and that's extended the CD. Right, so you've extended that. Now, every time you do this, you start off with this one. You call that 1. Right,
Yes.
that's your unit circle. Always. So the radius is always called unit 1. But this one here is the square root of 3. Which is about 1.7. So the ratio of this 1 to this is 1 to 1.7. So like Fibonacci is 1.618. This is 1 to 1.73 or 2. So, something like that, really, So every time you do that, you make this one your radius, and this is 1.7 bigger than this. And every time you do it, you will gradually increase in size, but you will extend the straight line through the perpendicular of whichever Vesica Pisces you're using. You'll extend the perpendicular. So this is to say that if you have vertical and horizontal, if you start off with this line here and you say it's an equal elevation, you call it horizontal, you will necessarily generate this one, which is the perpendicular bisector of this line.
Right.
Works in construction and everything, this. But every time you do it, you make a perpendicular bisector and increase the length of the line by 1.7. Obviously, this is if this is a radius, then this is a radius, and this is a radius.
Yes.
So once you've done it a few times, you are extending it by the initial radius by 3. This being the square root of 3.
Absolutely. Yep.
So, and that can just go on forever. So once you've started off with one straight line, you can necessarily extend the perpendicular to infinity, geometrically. Now, I'd say, because you can do it geometrically, you can definitely relate that geometric to reality. And if you can establish a horizontal, well, you can have perpendiculars at any point along it. I know what. Just don't even think about it. It's just reality. All of the horizontal planes are parallel.
Yep.
And you can extend these perpendiculars. I mean, this relationship that you do with these straight lines can be done with any point. Any point within this array, you can do exactly the same thing with. So once you have a water level establishing a straight line, then you can extend that straight line with these geometric principles. So really, what they have to do, or what's what Rams was doing, was denying these geometric principles in reality. Was there anything else, Kev? Because
No, that's
probably
perfectly clear.
you know, like there's more, right? We save that for another time.
Yes, indeed. Yeah, and that's the other part I wanted to
Yeah.
get to. But this is perfectly clear how you extend a line using
And
only circles.
this is a
Radius
yeah,
from the first
great
radius.
tool. Right, so this is your initial straight line there, but
Yep.
if you add a line segment or whatever from there to there,
Yep.
then that's on the same straight line.
Same line.
And
Yep.
you could zoom in there, and that would definitely be on the same straight line.
Absolutely the same line.
When we go over the other bit, right, that comes a problem. You being able to place these lines on top of
Yes.
each other,
Yes.
which is obviously geometrically. I was hoping to get there, but obviously it's not. This arena isn't ready for this sort of stuff yet. So hopefully, if anybody wants to come in and get involved with any of the geometry, then we can go back on that level. Let's get back to Discord.
Yeah, it seems to me that what happens is that this is all well and good for most people in geometry and in this application, and it's definitely provable that that's a straight line segment that can go on uh, for forever, right? If you just keep doing that over and over and over again, you will extend that straight line, that horizontal straight line forever, and the verticals will extend forever.
Mm-hmm. And the
But
water level test that we've got is
yes,
purposely in pieces so you can extend it. Like more people that want to come and join, the better.
absolutely.
You'll come with a 100-meter water level or whatever. It doesn't really matter.
So where would you say the cog disc enters then? Is it the moment they realize that this geometry that you're showing that's absolutely true and it's mathematics can be done in reality? Is that where the glitch happens? That's where the aporia sets in?
Yeah, I think it's probably got something to do with the fact that ECV, right? It's real, existential. It's so real, it becomes too much. Because we do relate this to reality. This is where the level, the water level is. It's in reality. And it is because of a modus tollens we did right back at the beginning. Probably a little bit too triggering. Probably shouldn't have done that. You know, upsetting as modus tollens are. I don't like playing those sort of games, but
Yep.
we do actually have. Oh, Jerry's. I don't know whether Jerry's around or not. We did have a conversation earlier. I don't know who was it. Somebody mentioned something, bringing it in definitions. Oh, that was it. It was Quiet Riot, and he's been very quiet ever since. He brought in some definitions. Let me. I'll just shift over here so I can get this. This is sort of, we were having a bit of a mess about, and as we like to do around here, we're quite into logic and logical statements. So a couple of things got added. Check this out. This is something that we did, and something that Jerry and a few of us got involved with. Mainly Jerry though, right? Jerry started this off. Quiet Riot came in, and I think this is genius. He came in with a definitional thing about Earth, I think it was. And definition 1 said it was a planet. And then definition 2 said the land, or, you know, the stuff of the ground. And we said, well, we want to go head to head. Let's go. And we can probably prove definition 2. And that's the definition that we use, the soil, the ground, right? And for him to have his definition, and he obviously didn't have a definition at all. He just said, I'm using definition 1. And we said, well, we can prove 2. Can you do 1? And Jerry came up and said, I've got an argument against his definition 1. I went, okay, then off you go, Jerry. Does anyone want to have a read of it, or do you want me to do it? I'll do it in my best, Jerry. Anyone want to be Jerry for a bit and read the logic argument? It's the argument against the planet. So the argument says a planet is a celestial body. Celestial means of or pertaining to the sky. The horizon is the horizontal separation line between the earth and the sky. Ergo, the earth is not in the sky. Also, the horizon is the horizontal separation line between the sea and the sky. Ergo, the sea is not in the sky. If the earth is in the sky, it is a planet. Earth is not in the sky. Therefore, Earth is not a planet. That's an argument. Thank you very much, Jerry. And the On the Level crew, obviously, putting it together. What's you liking to that? I quite like it. It's got an elegance to it.
Yeah.
How can it be celestial? That's good, isn't it? So, feel free. Take it away. Try it out. Give it a spin. Whenever you hear the planet argument, now here's a nice rebuttal. Thank you very much, Jerry. Welcome, paper.
Hello, hello.
Hello. What do you think of that?
Give me a sec.
Earth isn't a planet, yeah? Perfect. I like it. I like nice little simple arguments. So what did everyone think of last night? It was a bit much, wasn't it? Full on. Fucking crazy shit. I don't know how many more of those I can do. Too much model affliction. It's painful.
Seems the humps and the drops are doing a lot of, shall we say, damage to some people.
Bringing the hump back. It's a contradiction, isn't it? Like, it's an obvious contradiction. You can't have both. And, like, one leads to the other, and you go round in circles, and eventually you end up mad.
Yeah. It's twice today I heard it has to, but it has to be from two different people.
Yeah.
Got out blue.
Yeah. SE's got a video out. Anyone wants to, should really listen to that, because there is a rather large thing developing about elevations of horizontals. A bit like what Rams was trying to do then. He was trying to move horizontal, move the water level away, and add a slope. Only a little one, but still a slope nevertheless. He just didn't want you to notice it. But there is a slope, and horizontals don't slope. Yet, certain group of people want horizontals to have a differing elevation. If you want to learn more about that and the ongoing saga, then shoot over to SE Montreal's channel. Put a link out there if you can, SE, in the chat. I'm thinking of actually going over it and putting a Buster thing to it, because some of the things are quite good. Not wanting to say that Blue's been drinking or he was medicated or anything like that, but it didn't seem his sharpest, put it that way.
Yeah, he was struggling a little bit there. Yeah, it's a tough one.
I'm guessing it's a little bit hard for these guys at the minute, because I mean, I don't know who Rams is, right? He says he's been around for 20 years on the internet debating. That was strange. He wanted to go to definitionals, saying that. But he's been around, so I don't know where he's been if nobody else has known him, I think. Unless it's just a new character that he's got. And I don't know why he's come here in particular. It just does seem strange. We are dealing with a logic night, so try and work
I
some
would say
shit
that
out.
this example is very good, but I would add in last statement, because he's talking about the earth and the sea. In his last sentence, it is only earth. He should add also sea. If the earth is and the sea is in the sky, etc. This
Yeah.
last sentence, because he is talking about separately about sea and about earth.
Yeah.
But generally, for me, it's very, very much okay.
Yeah. It was a one of those things that it's quite simple to see once you see the argument being made, but it's genius at the same time, because it is that simple. It was always there. So yeah, thank you very much, Jerry. And just remember, that's always there. Anybody can make these sort of things. Most of this stuff, like you say, nothing's new under the sun, but sometimes shit's right in front of your face and you don't see it until somebody points it out. There you go. SE talking about LIGO. I know it's not really for most people, but anybody that's listening to us obviously has a hand within an argument, a little bit more of a geometric grip of what's going on. And this saga, the elevation change of a horizontal plane at LIGO with straight lines, is going to be going for quite a while. Don't know. I think people will be going mad quite soon. I wouldn't be surprised if LIGO have to change some numbers sometime soon. Videos might start going down, disappearing.
Yes. Lost of technology, etc.
Yeah.
We lost footage, we lost technology, and we cannot figure it out what the LIGO is.
Somebody
these numbers.
mistakenly put some wrong numbers on the elevations, and it's not actually like that. It's, because I wouldn't want Blue Marble Science or Rams or somebody like that defending, construction projects.
Well, apparently the computer that they logged the original numbers was lost, and they had to erase the other ones, and
And we've
You-
just lost them.
yeah.
You can invent many excuses, so this is easy part.
So yeah, please watch the Blue Marble one if you want to head up on the saga, because it is going to get much more interesting. Shout out Blue Marble Science. That was a good conversation with you. It was late night. And whether you've been drinking.
Yeah, it was a good convo. It was cordial. Yeah, shout out Blue.
So I don't really know what else we've got, because I'm having the I don't know whether you call that a debate or whatever. And it does seem like we've got I can't do many more nights like last night, because that's painful listening to somebody model afflicted. It's painful to watch somebody who's on the searching for truth supposedly, but being fully fed into a system that it's just bullshit, but knowing it's bullshit at the same time. Tough.
I will have to agree. That was fairly painful.
And on Friday as well, that one was far more I'd say not tough, but in a different way. That flat earth math, that's delusional stuff. I tend to just sort of forget about it, but I really should be going over the stuff he said. It's crazy, but I've become accustomed to it. People in this arena get accustomed to hearing really stupid shit. Really stupid.
Regarding flat Earth math, I think I have two questions ready for his calculus and this measuring curved line, but maybe I'll wait for him if he wants to come, or just will pose that questions later too, because it is not about him only, because there are two problems with that measuring angles to a curve and using this calculus supposedly. So I have two difficult questions for people like flat earth math and his measuring curvy angles.
I think it's quite clearly false, so I can't see how he'll come, because he can. The only way math can deal with that, keep calling him math, is to obfuscate it and not answer the question. Pretend it's an argument in bad faith or something. Say it's part of your blind spot.
Yes, but I can use his words, because from what he said, we know what he's going to do with that curve angle. And that question would show something, I guess, because he's saying what he's doing, that he's straightening the curved line and he's zooming in, etc., to make it straight, like seemingly straight, which is for me very strange. And at the same time, he's saying that he's making, he's measuring angle to the curve. So this is for me just nonsense. But I have prepared questions for him.
Oh, it's sort of what we just went through with the debate of can you extend the straight line, right? The perpendicular.
Yeah,
And he's
But-
zooming in, but we know that you can't zoom in to get a straight line.
Yes, but my question is, so I pose it now. If they are trying to measure angle to curved line, and in that scenario, they are trying to prove that verticals are divergent. So first thing that is strange, that if he is calculating angle to a curve, so why he is making this line straight, even seemingly straight? He is just like undoing what he is doing, because if it is curved line, so let it be curved. Why he is making it straight? So this is first question. And second question is about angle. We were talking with Flat Earth Math about the circles that you make. You are making circle, and this portion of the circle is your angle, etc. And he admitted that with curve you would have different portions of a circle. But if, for example, this angle that should be measured from your position to another divergent vertical, and let's say 69 miles away. So at the same time, he's making this curved line straight, and he's diminishing this section, because to make it seemingly straight, he has to cut this curved line into shorter and shorter sections, which are seemingly straight lines. And at the end, we have this point of intersection between vertical and curvy horizontal or whatever. And he's saying that according to calculus, you need the most close point to this point of intersection. But we are measuring supposedly distance 69 miles. So why he's seeking the closest distance? He said even on atomic level, so as close as possible. But this divergent vertical is 69 miles away. So why he is shortening straight line? Sorry, curved line. This is just nonsense. He's doing opposite what he's supposed to do. So he's deliberately calculating angle at wrong position, at wrong distance, because it has to be as close as possible. And we know that according to this example, this divergent vertical should be 69 miles. So he cannot do that. So measuring this angle at the point of intersection or near that will not give you any proof for divergent verticals.
It's not divergent verticals though, is it? Over 69 miles. It's 1 degree drop of the light in the sky over 69 miles.
But when he was talking about I think that he was talking about Flat Earth Math, was talking about divergent verticals. But still, it doesn't matter. We are just trying to measure angle between this supposedly vertical at distance of 69 miles to a curve. And
well, it's not though, really. I mean, let's. If you give them that, then you're agreeing to the fact that if you measure a 1 degree change of a light in the sky as you travel 69 miles, you're assuming, like somebody else might be doing, that equates to verticals. But it's just a 1 degree change of the light in the sky.
Yes, of course. I am not I am not assuming that I'm just going with their what they intend to do with that, because they are trying to prove that verticals are tilting or divergent or whatever. And they say that at 69 miles, this vertical would diverge from that original at the point 0. So between them, there is 69 miles distance, and they are trying to measure angle at the point of intersection of original vertical.
Yeah, well, that's what we would stating, I think, that that's impossible. Flat Earth math agreed with it.
Yes, yeah,
right?
practically
To
impossible.
say that, well, it is impossible, right? It's impossible because you need to measure the angle at the vertex, and the vertex to them is where the monad is, right? They can't get there.
Yes, I know, but
So to assume that that's the process that you have to go around, well, it's not. You have to associate it in a different way, right? You have to literally imagine that an angle that you're measuring to a light in the sky can move, right? You can measure an angle to a light in the sky using Euclidean principles, also using Euclidean principles and a nice, neat little trick of similar triangles by assuming a circle that you can then assume that there are no parallels.
Yes, but my point was not about measuring angle or lights in the sky. I am referring strictly what Flat Earth Math said about this calculus, and his claim, and not only his, is that you can measure angle to a curve, and he is supposedly doing that using calculus to measure curve of the level or whatever, what he's saying. And according to his own words, he is doing it wrongly because he is measuring at
Has Discord crashed? I think it might have done. I might be let me see if I can. Discord has crashed entirely. I don't know if my computer's still running. Looks like everything else is going. I can't. I don't know what's going on here. Discord's just crashed. There we go. Discord's coming back. Do you want to?
with this guy Emerald, who I don't know who he is, in fact, but and Red Rhetoric, he was doing that, and Ruchif again with this in this conversation with on Maktoons. So this is normal thing for them, straightening curved line. So Flat Earth Math was, and they were referring to calculus always, because this is supposedly what calculus is doing, straightening curved line.
Yeah, that's the whole point of calculus, is literally to mathematically equivocate the two. That's what it's for. He was probably talking about, well, I can picture it in my mind, he's talking about shortening those curved sections, right?
Yeah.
Yeah, he has a right angle. And it's of course not on the circumference, it's way up in the air between those My point here is that when you're using calculus, you are taking this right angle triangle, where the hypotenuse in this case is the 6 to 9 miles you're talking about. Shrinking it down to the point where you basically have shrunk it down to a point on the circumference. It's no longer a triangle at this point. It's just a point. And then they will tell you at that point, the curve and the straight line is the same. They're equivocated now. Ta-da!
Okay, but it doesn't prove anything in distance of 69 miles or whatever.
No, it doesn't prove anything at all anywhere.
Yes,
And of course, it doesn't change what an angle is, which is the inclination of two straight lines so to one another. So, I mean, you can try and obfuscate as much as you want.
Yeah, so this obfuscation is just a visual trick, and Rumpus was doing this a few years ago. So everybody on their side is doing the same thing. They are trying to visualize that by zooming in, as Flat Earth Math said. So he's not the first, of course. Everybody is doing that. Red's rhetoric is doing that. Ruchif, Rumpus was doing that. So zooming is for them proving something, because the curved line seemingly is apparently straight, but in the fact they are trying to undo their claim that you can measure angle to a curve. If you can measure really angle to a curve, so what's the point of straightening curved line? Simple question for them.
Yeah, that's a good question.
Because their claim is that you can. And for example, this refracted curvature was kicked out from debate because he repeatedly said that you cannot measure angle to a curve. So McToon kicked him. And they are claiming still that, of course, you can measure angle to a curve. So question is why they are trying to straighten curved line using calculus, for example. Why? If it is possible to measure angle to a curve. And the second question is similar, why they are changing distances. Of course, they have to, because making this curve seemingly straight, they have to make as short section as possible. So they are just undoing their measurements in distance, because if we are talking about 69 miles or so, it means that they are no longer measuring angles between that distances.
Are we not talking about the distance though, the 69 miles? I mean, you can't assume a 69-mile curve to measure an angle to, can you? I mean, like you need the relationship being that trigonometrical triangle, right? You can't do it without a 69-mile straight line.
I agree, but I'm talking about what they are trying to do.
Because they're just trying to trick people, aren't they? That you use 69 miles
absolutely.
and it is a straight line. But they're trying to pull a stolen concept to tell you that it isn't a straight line after they've took the angle.
Yes, absolutely. So they are trying to say that they are really measuring angle to a curve, but in fact they are not doing that. They are just doing old trigonometry, but via this tricks with calculus, it sounds very scientific, complicated, so people don't really know what's going on, so they cannot spot the trick. And the trick is that they are just straightening curved line to use normal
I don't think
trigonometry.
they're doing that. I think they're actually starting off with a 69-mile straight line. And then they're convincing people afterwards that it's curved.
Yes,
It's
of
the
course,
it's the
yeah.
opposite way round. They're not trying to straighten a curve. They're trying to curve a straight. Just in people's minds, right?
They are doing both. They are first they are trying to say that because level is curved, so this straight line distance is not really straight line distance, and then they are trying again. So they are flipping 2 times.
Yeah.
In calculus, they are just flipping again to straight. So they are starting from straight to curve level, and then in calculus they are reversing that. So this is just silly, but that's what they are doing.
I don't get the idea of the angle to a curve, especially when he was choosing a right angle.
What?
Flat Earth math. Let me get my screen on. Right, it might help because it all goes down to this again. Can you guys see that?
I can.
Okay, so it's this bit here. He's got this circle, right? Now he was saying at either end of the diameter, we've got a radius in the vesica Pisces, but it's still, it's either end of a radius. Where the line touches the curve, he has it as a right angle. Right, that's what he said.
Yes, because as you are zooming, he is zooming, and these 2 lines seemingly overlap, so they are both straight.
He
seemingly.
thinks, he thinks that this circle here is possibly at some point going to be the same as the tangent. Well, it's not.
It is not, of course, but seemingly is, and that's why my question stands. Why they are trying to seemingly or to see the curved line as straight, while they are trying to prove that they can measure to a angle to a curve. So what this process of zooming is for? This is my question.
Yeah, it's quite obvious there that the right angle causes the straight line. I mean, that's how you make a square. Right angles. I mean, you cannot have this straight line being the same as this circle. Mathematics doesn't work that way. There's no way to make them the same. Not even at a point. Because you can't even have the angle at a point. Doesn't happen.
For me, this is Francis Bacon.
Yeah.
Analytic thinking, because you
put into geometry, right?
You are, by zooming in, you are losing greater picture. So you just can see only one thing, tiny part of something, and you maybe you cannot understand what it is in reality, because you can see only one part, one chunk of the puzzle, and that's it. That's the trick, to make it analytic. Zooming in, to lose the whole, to focus on tiny part.
Yeah. When you can see that it's the same pattern repeated through it all. That there is no difference between the circle and the straight line. The circle is always the circle. It's scalable as the circle, and the straight line's scalable as a straight line. They'll never be the same thing. Can't make the circumference of the circle into a straight line. Mathematically, it's impossible. You cannot do it. They've proved that you cannot square the circle. It's just not possible. In fact, it's been proved that it's impossible. You cannot do it. It's been proved that it cannot be done. So why Flat Earth Math thinks he can teach that it can be done is very fucking strange. Obviously, it might be helpful. Oh, look, here's Rumpus. I thought you'd done a Jesse Kozlowski, Rumpus. Welcome back. We don't understand what a tangent is.
Of course, of course.
Remember that time, Rumpus, where you had to actually look up what a tangent was? And then you had to finally admit that, yes, you were wrong, and we did actually know what a tangent was. It was unfortunate for you.
When Rumpus admitted he was wrong, I remember that day very vividly. Yeah.
It is recorded. So it is out there. If anybody wants to go back and listen, check them out. Who wants to go back and listen to Rumpus, though? It's not worth it. Really.
I think that it was me who called Wolf from the forest. So I said, yes, Pages writing, yes, she is right. I called his name like 3 times and he appeared.
Right, so
But
can
in
you
fact-
see this? The thing that I've got here, because I've been messing about with this. Don't know whether you've seen this or not.
Yes, I can see that. And
It's
in
got the
fact,
right angles there.
yeah, and this is what Rumpus was showing. I think maybe he has seen that what you are doing, and he is triggered because you are repeating what he was doing many years ago. This zooming in to show that this curved line is seemingly the same as the tangent. So this is his old trick.
Yeah, as well. I've got it set up, and they are right angles there, right? Straight line from A to B. You'll notice that there is a center point, right?
Yep.
Any ideas how you would make those perpendiculars different? You know, like what's the only way that you can manage to tilt those perpendiculars? Oh, Blue Marble and Rumpus. What are you watching this, Rumpus? This is geometry for you, mate. Keep an eye on it.
If you have circles, you cannot do that. If you have circles as circles, you cannot change this perpendicularity. This Vesica Pisces always will do this vertical line at the center.
Yeah.
So
yeah, but I
you
mean that
cannot
one's
change
always
that.
going to stay the same. But I mean, if you're imagining you're going to be like, if you're Larry and Jesse, and you need to get more, right? How are you going to get more than 180 degrees if you and your mate Larry before you pissed off, like before you disappeared?
You have to make one circle bigger and one smaller. Or
What
just
about lifting the center? What's this? If you lift this,
okay, yes, you showed this before, but I was talking about this center line. So lifting it, but this is in position, horizontal position on the same point on horizontal, but
make an equipotential triangle.
yes, you are making an equipotential angle of adjustment. Yeah.
But if you unclamp it,
yeah.
But you are just destroying the whole tangent. These at the sides, they are no longer tangents.
They are perpendicular though, right? That's how you keep the perpendicularity, but it's how you slope horizontals also, right? But the problem is that once you've done this with the infinite regression, right, you can't put it back, because you've got to try and put this point now back on this straight line, right? So we zoom in and we'll put that line back there, and then we'll zoom in a bit more, and you find that you can't quite put it on. We keep putting it back.
If it is 0, you cannot do anything.
Zero.
They will be parallel.
Look, no, you can't, because originally this was on the same straight line, but we've separated it, right? And you can keep zooming in, and you can't. It won't allow you to put it back, right? So you can get it as close as you can there, and then you can zoom out again, because you can't. GeoGebra won't let you zoom it in anymore because of the limits that they do. So now we're zooming it back out again. Right, now we're back to the original bit, right? But now we're going to go and zoom it out even more, because that's a straight line. These are all 90 degrees, aren't they? We've got it as close as we could. Now we're going to zoom out. Remember, this is just because we separated that straight line. I think it's going to be on top again. What do you reckon? Top or bottom? Yeah, top. Look at that. How did we do that? We made a circle. Made a circle because we tried to separate a straight line and add more angles to a straight line.
Okay, you can zoom.
You cannot put, once you've moved this line here from this straight line AB, you can't put it back. But that's how you have to do it. That's when Larry and Jesse measuring their angles. They're up here measuring these extra angles. It's a tangent there, Rumpus. Straight line. Perpendicular. Of course we know what a tangent is. Tangent point, tangent line, tangent plane. All touching the circle at one point and one point only. You can't have two tangents on one straight line, can you? Oh. Like FE Dogma does. But that's what he wants. He wants these right angles here to be right angles without the tangent. FE Dogma. He wants to get rid of the tangent, but even GeoGebra won't allow you to put an angle there without the straight line.
Yes, because it is impossible to measure to a curve.
Yeah. But it's only Euclidean geometry, right? They'll definitely have a not this geometry, so that they can measure angle to curves.
No. They say that they can, but they cannot. But they still say that using modern geometry or whatever, and with help of calculus, they can. But in fact, they cannot. They are just saying that this new tool is allowing them to measure angle to a curve. No, it is not. This is just a false statement. Maybe they believe they can, but they cannot. That's why I am asking these two questions. Why they are straightening curved line, and why they are measuring angle supposedly at the wrong point. So, because their claim is, and flat earth math claim was that he agreed on that with a conversation with me that yes, if we have a curve on different distances, we would have different angle because it is obvious. So why he's measuring at the wrong distance? He's making this angle at wrong distance. That's questions for them. So in fact, they are not doing that, but they are trying to convince publicity that they are doing, they are measuring to a curve, angle to a curve. This is just not true.
Well, you can't see the problem with Proposition 16, the one that they actually use, is it says that no straight line can be drawn that won't cut the circle. So you can't actually measure an angle down from that tangent at all. It's not possible because you will cut the circle. Yeah, that's what they imagine. That's why I think they imagine a change of position. Because they start off with A and B, but then they have to imagine themselves at the hump, looking down.
Yep. Yeah.
It's a complete shift of positioning, a relative, right? They shift their relative position in order to mind measure an angle that actually isn't there.
Yeah,
that they can't possibly measure.
Yes, even Blue Marble Science, when he is depicting these angles between horizontals, horizontals and verticals, he is referring to the monad. He's drawing this blue marble and with the center point, and this is this angle which he is measuring using straight lines, vertical straight lines, and using normal trigonometry. So he's not curving anything. But this angle is not on the surface of the Earth or whatever. It is in the center of their globe.
Yeah, they move it, don't they? Similar angles, similar triangles. You use the Proposition 5, I think.
Yes, and they are moving to the center of the Earth. This monad, this geometrical center, which is because maybe they know that they cannot measure angle to a curve, and they cannot measure angle on curved surface. That this is another thing.
Well, it's stolen concept, right? And that's half of the problem, right? The existential cognitive veiling becomes so real that they have to acknowledge that they're using actual angles with straight lines, which is Euclidean. To imagine that they're measuring angles to not curves to come up with non-Euclidean. No wonder they're going mad. It must take people of a certain age to be able to have their mind completely messed up like that.
Yeah, this is just, for me, sad story, generally speaking.
Yeah. Yeah. I feel sorry for you, Blue. I don't know. Your team that you've got Betty making really bad arguments. And were you here? Did you hear Brian last night with the Betty one? I'll get that out because I don't know whether we went over this. It's probably worth pointing out to everyone, especially if Rumpus is out there listening. He'll love this. Right, it might take me a little while just to find these. Maybe not. Yeah. Right, so Betty obviously is helping out, making arguments for the Team Globe, Blue Marble scientists. He's over there, he's talking to Mike, and he's obviously jealous of our argument, so he makes this one, right? Logic, he says. Logic. 1. If the Earth is a globe, then no verticals are parallel. 2, if no verticals are parallel, then level is not horizontal. Hence, if the Earth is a globe, level is not horizontal. But the Earth is globe. It is globe. Therefore, level is not horizontal, QED. That's advanced simplicity for him. And now I was saying to Brian, right, to get people, hopefully to get Brian to, do a little bit of logic on his own. And I said, so what would the black swan be for this statement? It took him a bit. And then I said, so it says if no verticals are parallel. So that's a statement that none. It's like an all statement, isn't it? It sets up perfectly for the black swan. It's perfect. Perfectly set up for a black swan to offer it up there.
Yes, in order to invalidate that statement, if no verticals are parallel, then level is not horizontal. So if you can find 2 verticals being parallel, you are invalidating the statement that level is not horizontal.
And don't forget the big one as well. He's thrown that in as well, a Brucey bonus.
Yes, and the Earth is not a globe, but still, this is a series of non sequitur statements in general. But
for Beddy logic, right? For him to be helping the Team Globe out, all you have to do is find 2 plumb bobs that are perpendicular to a horizontal. That's all that's needed.
Yeah,
isn't it?
yeah.
And you get quite a lot of bonus out of that, right? For such a little thing for you to be able to do. Look what you're doing. The level is horizontal, right? And the Earth is not a globe. I mean, thanks a lot, Betty. Well done.
And by the way, with this non sequitur, because his first statement or premise, if the Earth is a globe, so he is assuming.
He's offering it up, isn't he?
Yes, so he is assuming that, and on that assumption, he is making further implications, let's say. He's making implications. And how he is validating this premise that Earth is a globe in sentence number 4. But the Earth is a globe. So this is his validation.
Tis globe, everybody knows tis globe.
Yeah, tis globe, yes, because tis globe, therefore my first premise is validated. This is circular reasoning, sorry.
Oh. So, thank you very much, Betty. We have a helpful inside man letting the Globers know how to do logic, and also the fact that they can't do logic. They shouldn't, really. They should leave it on their own.
Yeah, maybe they should try, but they have to eat before to sleep well, because maybe they are not in good condition always to do that thinking stuff. Maybe sometimes upset, nervous, there are many obstacles to think clearly. Not always.
I'm just making a brew. Yeah, I really don't know what's going on over the last, I don't know. I guess this arena's crazy. Living in reality is just about enough for most people. I don't know why everybody's obsessed with it. Obviously, this arena, people are obsessed about it. But I don't know why people are obsessed. I don't know what the gain is. I don't know what the end gain. Sufficient cause.
I don't know. Also, maybe some kind of pride, or maybe some, yes, pride, which makes some people think that they are godlike entities or whatever. I don't know, because in my practical mind, I cannot see any gain. For me, it would be not gain for me. If, for example, someone said to me that, oh, you are so smart, you are godlike, that would be for me not a gain, because it would not give me any satisfaction to hear that. So sorry.
Yeah.
I don't understand, but maybe there are some people who really want that satisfaction made from false judgment of themselves, or other people can judge them wrongly, and they are making this statement that, or they can think that they are godlike, they are better than others. I don't know, because for me this is just nonsense. I would never go that way, but maybe there are some people who like that kind of thinking. I don't know. I don't understand that.
I'm still interested in seeing what's going on with LIGO and the angles that have been claimed by certain people. It's fascinating me, but I'm thinking that it's going to be left alone again. It's about time for people to avert their eyes from the hump and the drop and the geometric principles about measuring angles, getting more than 180 degrees, because it's obviously too much. It's too much for most people to even contemplate, because it's so far removed from reality that all you have to end up with is you end up with Euclidean anyway, just with the idea, a conception that not Euclidean's possible on Euclidean shapes. There's some sort of different sort of thing that gets imagined. It's very strange.
Maybe they will fix that problem. Like we said, they lost technology, they mistakenly wrote something somewhere. So now they will fix that. I don't know. There are many possibilities how to resolve that LIGO problem. But or maybe they will create someone will create a new false dichotomy. Whatever, you know.
I think it's got something to do with the angle to a curve. It seems to be pushing quite a lot, right? I mean, that is one of the biggest fantasies that you could ever have, isn't it?
Yes, this is good for me. I think that for them this is crucial point to measure angle to a curve, because on that it is based their calculation of their model is based on that. So on that possibility, and as we know, it is impossible. You cannot. So they are trying to convince people using tricks and zooming and calculus and whatever else they will use to convince people that yes, you can measure angle to a curve. And this is just impossible. And they are showing flat Earth math show with his conversation that it is impossible, because he was telling us what he is going to do in order to obtain an angle from a curve, and he was just undoing that. Maybe he didn't notice that he is undoing curve in first place, and then he is undoing distance to be measured. So this is just fairy tale, but this is what they demand. They demand a measurement to a curved line, which is impossible. Of course, in practice, it is impossible, and mathematically, even using calculus, it is also impossible. I think that this calculus, they are saying that they are using calculus to measure to angle to a curve, but in fact they are not measuring really to the curve. But they are saying that to make it like more credible to hear. Oh, calculus, this is very, very complicated thing. So, okay, if they are using calculus, they are very smart, and of course they can do that because calculus allows that. But in fact, I think they will reveal in time more clearly what they are doing with this calculus. And I bet that this is what I am saying now, that they are just trying to straighten a curved line, and they are just using the same optical trick using calculus. That's it.
Yeah, can I just point out to the chat, right? There's a new guy in here. Just let him have a play and he's all right. There's no need to stress people over as though you're crazy about a model obsessed thing. If he wants to come and talk about anything, just let him do it. Don't hassle anybody about this stuff. It's not representative of this channel. Thank you very much.
This the 404 Studios.
Yeah. He's just come in and said he's a pilot, and so obviously the chat goes crazy.
Come in, we'll have a chat.
Yeah. No, I would ask about a gyroscope, of course.
Well, I wouldn't be bothered, really, but you know, because we're not that sort of a channel. But if somebody wants to come in and brag about, I don't know, whatever, make a claim, but there's no point asking about certain things. It's got a small Class B. It's only a little plane.
Gyroscopes are on every plane. So
yeah, I know, but it doesn't. I don't think it makes anyone an expert in any of this just because you've driven a car or flown a plane. You know, it doesn't give anybody any extra ability or anything, really. So it's no reason to hassle people as well, especially when there's new people around. So please.
No, I'm just.
I'm not saying it to you, Paper. I'm not. You know, I'm trying to let everybody in the chat know that we would like a welcoming place that we do like to have. So yes, anybody's welcome to come in. And if you want to say anything, I mean, I don't know. I don't know what. We deal mainly in logic and geometry, so I don't know how you could relate it to anything of the stuff that we do, but personally, I think what we do here is we study level And there's a lot of people that like to have a different idea about it, but I'm not too sure that they've studied anything. They just go with dogmatic beliefs. I don't particularly want Rumpus. I don't think Rumpus can come in, to be honest. Blue Marble Science has already said he won't come in. He's still trying to work out his LIGO elevation problems.
Yeah, how about Rumpus giving us an update on the wrecked?
Well, he's got to
What's going on,
put
Rumpus?
his videos out first, hasn't he?
That's what he said, yeah.
Yeah. I'm going to be
I tried to ask
sorting
him
the
last time on Blues, but Blue took a hairy fit for some reason.
Yeah, protecting him. You were. Blue was
Yeah,
protecting
but Rumpus
him.
was.
Don't ask him, I see.
But he was willing to say it. He was more than willing. And Blue like, no. How dare you, SC, interrupt? Blah blah blah. And Rumpus says, no, it's okay, Blue. I'll take a minute. And oh no, how dare? Yeah, remember that, Blue? That's pretty snowflakey behavior there.
Yeah, he's 99% done, Ute says. It's nearly there. Just a few little finishing touches.
Almost there.
Yeah, Gadget. They're all keen to know, Rumpus. I mean, I think we all know that you're not going to do it, but I mean, it's worth trying. See whether we can get you to do the ranty. Prove us wrong, Rumpus. We say that you're not. Come and let us know when at least your videos, you're going to release some footage of the stuff that you did do when you were doing your Rumpus poll, putting it up.
You see how good we are? We're promoting Rumpus and all. You didn't even want to hear. Nothing.
Rec test.
We're promoting Rumpus here.
Who's going to be first? Who's going to do it first? The reciprocal Rumpus poll sightings for the final proof for the dogmatic globe from Bev and the On the Level crew, or Rumpus and the rec test? Which is going to happen first? Man,
I know where I'd put my money down.
Yeah. It'd be good if you could just sort of let everyone know the actual method that you're going to use, Rumpus. So some geometric drawings.
We know the method.
He's what? He's auto level sighting.
Well, he's got his stations, right?
Thermistor arrays.
He beat me to it. Thermistor arrays, yeah. And he's going for the 17-foot drop. He's going for the row bottom.
Completely bypass the Wallace.
The Wallace.
Yeah.
Yeah.
But you can't reciprocate it, so you never know. He could just be looking downhill, couldn't he?
Oh, you're saying he can't reciprocate it. You don't know.
He's not going to reciprocate it. So how do we know that there isn't just a drop one way?
I'm sure Rumpus thought to look the other way once he got there. Have you not done that, Rumpus?
Blue Marbles.
Don't tell me you're only planning to look one way.
He is, yeah. Yeah. He might come back next year and do the other one. And Blue Marble's really triggered by you coming into his stream and asking Rumpus. So he's having to come in again and say, like, look, you, SE, don't you go in there and ask Rumpus about his test? Protecting
What a
him.
snowflake. I was very polite, and Rumpus was very receptive, and he even told you, okay, Blue, give me a little, it's okay, Blue. But you insisted that I was interrupting. You never heard of commercials, and now, for the rec test, presenting Rumpus on such a date, boom, bam, boom, it would have taken 30 seconds, Blue, that's it. But no.
Because he doesn't want Rumpus to say. He's never going to do it. Everybody's saying, like, they've given up on Rumpus. I think they know. Like, it's like Rumpus is getting his Jesse card. He'd be like, well, we've emailed Rumpus. And he's doing all right. He's just had enough for a bit. You know, he got bored of people asking him to do things and asking him about his test. So he's just left for a bit. He's still going to do his test, though. Yeah, he said it in an email.
Maybe you think maybe Blue is afraid of his legacy, that if Rumpus pulls this off with the BBC and all being there, that he'll upstage Blue as the king of the blue marble science?
I think Blue only managed to get one of the 5 laws of Globe, didn't he?
He was in there, yeah.
Straight
He was in
lines
there
don't curve.
on the five laws of Rumpus.
Yeah.
He co-wrote one, I think. Yeah.
Yeah, the straight lines don't curve, is to my recollection.
Yeah.
Which was nice. Oh, what's going on? Drama.
There's the 5 Rumpus laws for you.
Yeah. Yeah, Rumpus. Why is his knock still going? He's done. Everybody knows. It's a pity though, because I don't think he's got the personality for him to be able to do the ranty thing. He's never gonna do a like a court case sort of thing, is he? Johnny Depp stuff. I mean, Rumpus wouldn't get away with that. I don't know what Rumpus could possibly do. Not what he's got to look forward to.
You don't remember?
Served his time.
You don't remember what he said?
Who, Rumpus?
Yeah, he has political ambitions.
Really?
Yeah, this is a study.
Nice.
Part
Yeah.
of. Yeah. If I recall
He
correctly.
does seem like a politician type. I can imagine Rumpus being a politician, local councillor.
I can see him standing up in the House of Lords. Objection!
In the House of Lords?
Well, maybe I was too ambitious.
You don't get into the House of Lords like that. That's a boys' club, that.
You have to start lower off.
Yeah, I think you'd do well to get in there. You have to have some family connections. And I'm not too sure Rumpus has got that sort of family connection. Although you never know. You never know. He's not flashed the 33s around enough. To be honest, to be part of that club. He might be trying to get in. But yeah, he's not done that enough. George was doing that forever. You might have noticed that. Put them all in.
George would never get into the House of Lords. He's American.
No, I mean flashing the 33s, you know.
Oh,
I don't think Rumpus does that enough. George was doing it all the time. He made his things, his signs, his targets, so that they were 33 arc seconds. He did, you know. All sorts of tiny little things that that they all do, just to show the club who's in the club. And I don't think Rumpus is in the club, to be honest.
I think he's like special forces, you know. When a disturbance needs to happen, like, you know,
Yeah, I think
derail a government.
that role was played quite well in the early days for Rumpus. He did all right at doing what he did, but eventually people got wise. And like the legacy is that there's no arguments anymore. But I think everybody's had enough of Rumpus. Rumpus has got no backing really on the Globe side. Think Blue Marble sort of might have ditched him. I think
No way.
Yeah, I think the sidekick Rumpus has been laid off. I think Beddy's the new guy. Thank you very much, Gadget, for your members. Click on the thing, get a membership. Now's your chance, you. You have to click on the thing to get one. To say, like, yes, I want one, please. Otherwise, you won't get one. Yeah, I think you have to click the thing, you. Otherwise, you will never get one. There's one waiting there right now. All you have to do is click the, yeah, go on, I'll have one. Thank you very much. Thank you very much, Gadget, and thanks from all of the people that got the thing. There is another couple waiting in there. See, Boris did. Yeah. Okay, so I don't know where we at. Obviously, Rumpus isn't going to do anything. Blue Marbles absolutely messed himself up, and seeing as we've got the I think I've got a video. There we go. This one. Right now. Oh, this is an old video. Okay, seeing as we've got a bit of time. Let me get this for you guys. Now this is FE Dogma. FE Dogma's been sending us loads of stuff. About his about LIGO and the elevations. He's sort of talking to Blue Marble about it, and everybody knows LIGO is it's two arms 2.5 miles long, perpendicular to each other, and they're straight, reported but of being the straightest thing in the universe for a fair few years now, right? So this video that you're looking at here it's an old video. It's 11 months, this one. Only got 300 and something views. Obviously, this is FE Dogma. Now, FE Dogma did the twin tangent, and he's going to go over this. I think we've probably been over it a few times. So everyone, jump in the thing, and we'll listen to this. It's a little bit slow, so maybe I might have to speed it up a bit. Playback speed. Let's try that.
About a year ago, I uploaded this video asking the question, was Hanford LIGO built on a flat Earth or globe? So I used 5 top of slab elevations.
I don't know why you did the video, right? Was LIGO built on a flat Earth or a globe? It was just built in reality, right? So what's up with that? Why does there have to be any other additional things to it? And I don't get this. This is what has amazed me. We all live in reality, right? I don't have a model, so there is only reality. And like, you can't know that much. Nobody knows everything. So I don't get what the big deal is.
For each arm,
These
which
people.
I got from the LIGO blueprints. And then I compared these elevations to both the flat Earth and the globe model of a level line. Now, from a
He's
surveyor's
setting
point of
himself
view,
up.
a level line of equal elevation on a flat Earth would be one and the same as a horizontal line, and on course on the globe, that
It's
level
not a
line
flat
would
Earth.
curve down.
It's
from
just
the
in
horizontal
reality,
line.
right?
And with those definitions of a level line, I showed that the beam slab would be a curved line on a flat Earth.
The beam slab would be a curved line on the flat Earth, he said. Like, this concrete slab, in reality, that is straight, the straightest thing in the universe, he's decided that on a flat Earth, it would be curved.
It's unbelievable.
Like, not fallacious thinking that straight off, right?
This is just nonsense.
Yeah.
Pure nonsense. Yeah.
So this is what he's done, right? And obviously this is about, I'll let it go on.
Straight line on the globe Earth.
This is him setting
Now,
this
6
up.
days ago, I got this.
Right, so that's the beginning of the video. 47 seconds of him setting up a straw man. Right, he's letting you know something that he's done in this thing. Switch the kettle on, Flores, please. And now we've got to this point here, where I made one comment. You have 2 tangent points on the same arm. And then this is where he goes into his
Message from Bev on that video. You have 2 tangent points on the same arm. Well, I started my reply with, this is a comment out of the blue. But
it's not a comment out of the blue. It's because I watched this video and seen that he had 2 tangent points on one arm of LIGO. That's why I made the comment, you've got 2 tangent points on the same arm.
I added, hopefully by now you understand that those topic grade elevations for the beam arm slab form a curved line with your definition of a level line.
So, did you hear that? Hopefully by now you understand that those top of grade elevations for the beam arm slab form a curved line with your definition of a level line.
Wow.
Like, no, it's not curved, it's a straight line. So why is he talking about my definition and what would happen? He was talking about flat Earth earlier. It's not flat Earth, it's reality. And we can prove this. But this is the bit that now you have to listen to what he says.
But yes, there are 2 tangent points at 2 different elevations, but I only use a single tangent point for each arm.
Right, so LIGO is on a plane. That plane has 2 arms in it, but they're both within the same plane. And he's got 2 tangent points, one on each end of an arm. Whether you want to have 2 or not, like, but so he says, yes, there are 2 tangent points. He's wrote it out. There are 2 tangent. This is his comment reply back to me.
Now, a little later, I found out that when I was sound asleep on my side of the globe in Asia, my video was actually the center of a multi-day debate, and this also included...
It wasn't a multi-day debate. We were just pointing out that his video, he's done 2 tangents on one arm. Remember that, and remember what he's going to now say.
The Blue Marble Science and Ruhif standing up for the globe. A few days later, I got a
Do you hear that?
My video was actually the center of a multi-day debate, and this also included Blue Marble Science and Ruhif standing up for the globe.
Standing up for the globe?
Standing up, the defenders.
Really? Effie Dogma, this guy, has done a drawing where he puts two tangents on one line. You point out to him and show everybody this is where he's done it. Look at this on this video. There's two tangent points here. And now all of a sudden, Blue Marble and Ruhif are defending the globe.
Yeah.
But it's not the globe. It's FE Dogma that's put two tangent points. Like, is he assuming that's the globe? Is he assuming that the two tangent points that he put in his video needs a globe defenders to defend the globe because he's put two tangent points on his video?
Obviously, that's his globe, his monad.
Yeah, and good boy Blue and Ruhif. Well done for defending
Absolutely.
his monad that he's put two tangents on, right? He's admitted it. Yes, there are two tangent points. So on this plane of the arms that LIGO's, he's got two tangent points in. He's admitted it. And Ruhif and Blue Marble Science were defending the globe in defending the twin tangent conundrum. It's only a 6-minute video, this.
A few days later, I got a message from Mike Jones. Did you hear Blue Marble taking a beating trying to defend your twin tangent paradox today, little Betty? Well, sorry.
That's Mike. That's the way Mike works. Again, it wasn't me. It was Mike. But nice for FE Dogma to point out how triggered he is. He put it in a video.
Sorry, Mike. I know you probably want to play bait, but I am not your little buddy. But more interesting is, why do you think two lines, each having one tangent point at a different elevation, is a paradox?
Why do you think? Look, he's saying, again, two tangent points. Why do you think it's a paradox? Having two tangent points on one arm. Or call it one plane. Doesn't really matter.
He was stuttering all over the place, trying to help obfuscate away the fact that this video claims two tangent points on a single straight line. You realize how stupid that is, right? Well, yes, that would be stupid, but I do not claim that a single straight line is tangent at two different points.
Oh.
Now, this is the graphic that I use for that arm. So, Mike, where did I claim this arm has two tangent points?
See this horizontal line here? Goes from the end. Look, it's got a tangent point. And then this point here. Watch this, because this is very clever trickery he does. It's the corner station, this end here, of this arm here, corner station. Watch.
So here's a question for Bev or any one of his followers. Can you please provide a timestamp in my video where I have a drawing or where I say the northwest arm is tangent to the 578.33 foot elevation at the corner station? Yes, the southwest arm is tangent to the 533 point.
Oh, yes. The corner station is a tangent. But not in the other picture where he had the corner station. It's on a different picture, but it's still the same fucking corner station.
That's right trickery, man.
Like, what?
This is his argument. Best argument.
Yeah. It's not the same straight line.
Swapping
but it's the same
pictures.
straight corner station.
But on different picture, and this is his excuse.
Yeah.
Very good.
AB, the line goes from A to B, and there's a tangent at A and a tangent at B. But he wants to separate B and put it on a different line. Well, okay, FE Dogma. Apparently, when you defend this as well, you're defending the globe. This needs globe defenders defending 2 tangents on one line. Gets worse as well. Gets worse.
0.78 foot level line at the corner station, but not the
Yes.
northwest arm.
Yes.
Here's something you guys might want to think about.
Right? It's something you might want to think about. This is what he's saying, right? This is how FE Dogma gets out of the twin tangent. Look.
So line BC is tangent to the circle at point B. And line AB is perpendicular to line BC at point B.
He's got a tangent here, this circle. He's got a circle here. And he assumes that the tangent at B's on the side. He's doing this for the globe guys, right? The globe defenders like Blue Marble and Ruhif. He's saying, thank you, Blue Marble and Ruhif. I'm going to make a mockery of what you were doing.
Yes, but still, the conundrum is not resolved because we are supposedly on one globe, not 2.
Well, this is put it on sideways. It's literally put a circle on the side of LIGO, A, B, C. These are the arms of LIGO. He's put it on the side. Now, he's not even put it underneath. He's literally just put it on the side.
Yeah, so that would be vertical. This AB would be vertical?
No, it's just a circle. It's literally just drawn a circle on the side of LIGO so he can make it a tangent. That's not the Earth. That's not nothing. This is just A, B, and C, and he's just drawn a circle on the side of it. It's like you could just draw a circle here and a circle here and say, look, this is another tangent point.
But sorry, but this line AB is not tangent to that circle.
No, I say you'd have to draw another circle here at A to make that at A point tangent, and then he's made B point tangent over here. Just drawing circles everywhere. That's how he solves it, right? The twin tangent that he's set up. This is how he solves it. Just draw a circle on the side. I mean, the Blue Marble and Ruhif were defending the globe. He just drew a circle on the side of a line.
But you can also
Instant tangent.
Yeah.
You can also draw a circle on the bottom at point C also.
Yeah, you can anywhere. It doesn't really matter. That's how FE Dogma gets around the problem that he's put out for everybody else. Everybody else is trying really hard to solve this problem when it's impossible. It's an impossibility. You cannot solve this apart from just drawing circles on the side. Apparently, that's called globe defending. It needs Blue Marble science. I bet they didn't do that. Go for a little bit. This is like a geometry lesson from FE Dogma.
Do you really think this means that line AB is also tangent to the circle at point B? But wait, there is breaking news. Now, earlier today, I left this comment.
Right, look. Now, listen to this. This is his comment that he's left for me.
On Bev's latest upload. Yes, there is a tangent point at A and B.
Yes, there is a tangent point at A and B. Which is what the thing I said, you realise you've got 2 tangent points on the same line. And now he's saying, yes, there is tangent point at A and B. So thank you very much. Pointing out exactly the first thing that I pointed out. So I don't know why he's got a video doing this when he's actually agreed with me here. This is the only thing I stated. You've got 2 tangent points on the same straight line at LIGO. Yes, he has.
Can anyone please give a timestamp on my LIGO video when I say that line AB is tangent to the 533.78 foot elevation at point B?
It's got 2 tangent points at A and B. That was the statement. Please, somebody tell me. How am I at fault here? Hey, FE Dogma, you do realise you've got 2 tangent points on a straight line there, right? And he's going, yes, there is a tangent point at A and B.
A and B, there are extremities of straight lines. So
Yeah, 2 points at the end of the same straight line. And he's admitted it. So there's no controversy or anything, right? He's agreed with me that he's got 2 tangent points on a straight line, which is impossible, but he's admitting it. There's just different elevations. He thinks he can get around it by saying the different elevations. Doesn't work. Blue Marbles in the chat. 1 tangent per line. He's got 2. Blue. I don't get it. I really don't get it. Can everyone see that? Blue saying only 1 tangent per line. So how's he got AB? A tangent at each. He's agreeing to it. Yes, there is a tangent at point A and B.
yes, so these are 2 extremities of one line.
Yeah.
Line AB. So line AB has 2 tangent
Tangents.
points.
Yeah.
Yeah.
Impossible, but that's fine, Blue. You want to try and make it into a different line? You can't. It's AB. Simple as.
I'll wait.
He's going to wait.
Now, a few minutes ago, I noticed that Bev replied, and there you go. There's a tangent at both A and B. AB is a straight line, and there's a tangent point at both A and B. Finally, we get some honest talking. We all know that's impossible, right? Well, unless you have 2 different circles. Thanks for being honest about this. So I replied, you're welcome. But there are 2 different circles.
Hey?
Where?
He admits it.
Yeah. Yeah, look, he's agreed with me. I've said finally some honest talking. And now what's he going to do, right? He's going to agree with us, but not agree, right? Still, they've done something wrong somehow. Carry on.
One based on the 529.63 foot elevation at the end station, and the other based on the 533.78 foot elevation at the corner station. So it looks as though you agree with me. Line AB is not tangent to the 533.78 foot elevation at the corner station.
Like, I don't know what you're agreeing to. You're agreeing to 2 tangent points on one line. It being impossible, I can't understand why you're still going along with it. You can't just say different elevations. It's impossible. Blue Marble Science still going with it. I'll have to get this as a clip when we come back. Blue Marble Science. Everybody gets it apart from us.
Blue told me yesterday that there's only 1 tangent point in that whole complex there. Didn't you tell me that yesterday, Blue?
Yeah, there's only 1
now
tangent
you're saying
point.
there's 2?
There's only 1 tangent point per plane, right? Line.
That's right.
I take
And now
it they
he
are in the
envisions
same
2?
plane. Yeah.
Now he envisions 2? Yeah.
Yeah. Play there, look, 2 lines, Bev. 1 tangent on each line. So he does have 2 tangents, right? Blue Marble Science has agreed with FE Dogma to the 2 tangents that he has. He just doesn't think they're part of the same line, even though the corner station does belong to both of those lines. B is common to both AB and BC. It has B in both of them. It's a point, a common point. They call it the apex, the vertex, but it's the common point of the 2 straight lines. Of course it belongs to both lines. But somehow, elevations somehow I don't know how elevations matter to tangents when it's impossible to have two tangents to the same straight line. Otherwise, unless you have two different circles, like I say, just add another circle on.
Well, I really doubt if he's going to be in agreement with me. But Bev, why don't you try Googling surveying horizontal and level lines?
It won't say anything about two tangent points to the same fucking line. Nowhere ever would ever have anything to do with that. Only on a FE Dogma video.
And here's just a few of the results when you click images. So why don't these diagrams match your definition of a level line?
What
and
diagrams?
Why do they match my graphic that I use?
I'm talking about two tangent points on a straight line. Right? Not about level, not about anything else. You can do whatever you want about all of that sort of stuff. You want to have a conversation about that. The conversation is about two tangent points to a straight line. Talk about obfuscation.
For my LIGO video. So Bev, here is something to think about. We know that the concrete slab for the LIGO beam arm is a straight line.
Absolutely we do. We know that for a fact in reality.
We also know that when we use your definition
of
a level line, the elevation for those beam arms form a curved line.
No, we don't. We know in reality those arms are straight. We also know in reality that level is a straight line on a horizontal plane, and that does not make straight concrete arms bend. Unfortunately. FE Dogma. Shit. Trying to take me out.
Now, what are the odds that I could take metabunk Earth curvature calculations, apply them to the globe definition of a level line, and come up with elevations that are within a fraction of an inch of the given elevations of those LIGO beam arms?
So the LIGO beam arms elevation profiles would look straight, right? Because it's a straight line. Straight lines have an elevation in elevation profile of a straight line. Don't they? Don't they?
For me, this is just more evidence supporting the fact that we live on a globe. And finally, if you are going to continue with this twin tangent paradox, can you or one of your followers please provide a timestamp where I make the claim or have a drawing that shows that the northwest arm is tangent to the elevation at the corner station?
Okay, right, get back onto the Discord. Close the stream down. FE Dogma. I'll just get this. See this picture here now. This is a picture taken from his video. And you can quite clearly see on this picture. He has a tangent point at this end. And it's a tangent point at this end. This is quite clearly one straight line that says horizontal line tangent to the end station, the concrete slab. So this is a straight line. Straight across there, horizontal. And then here, horizontal line tangent at the corner station. Here. Tangent point here. And a tangent point here. Tangent. Horizontal tangent, horizontal tangent. Tangent here, tangent here. That's where there's two tangents. That's where you've put it. It's on your drawing. It's got an arrow pointing to them. And you see this here. This says auto level horizontal line. Pointing up. It's got an auto level and the horizontal. Here, this guy. So this one's sloping upwards. And this one's not sloping upwards, or is it? It's horizontal running across the page. Maybe it is going up a bit. Don't know. Some really weird elevations that right, Blue? Why's a horizontal got a change in elevation? 529 foot and 533 foot. What's that about? Anyone know? But it's got a 4-foot elevation change on a horizontal. Not too sure about that. Anytime anybody wants to come and talk about this, Blue, or go and cry to your buds, FE Dogma, tell him when he gets up, because he does come round here a bit to sort this out. He can't sort it out. He's already drawn a circle on the side of it. There's another one. Two tangent points. One at B and the other one at B. A, B, B. I hope Blue does go live. I really do. You deserve to give Rumpus a bit of space. I think Rumpus is feeling a bit left out. I think he might be thinking that you've left him behind. I think he's... Don't know whether Rumpus was becoming a star and they've fallen out, Blue and Rumpus. I think you should get back together. Made one hell of a team. Get in there, Rumpus. Get Blue going live. Let's do a rec test update. Put the finishing touches to your videos. Get soundtrack. Get Blue to give some of that bluegrass shit that he had in his video. The one he took down yesterday. His first video.
If he plays the banjo, I'll even rejoin just for this one occasion for the wrecked update.
Get Blue with his Hilly Billy sort of band in the background. Blue and Hillbilly Blues. Hilly Billy Blues Band. Hillbilly. That's or is it Hilly Billy? I don't know. Don't know as far as Blue's concerned. Gadget's still trying to get Rumpus to come in. I think Gadget had this thing. He really liked George. He was going to have a meal out with George. I think you might be able to fill that gap, Rumpus, in Gadget. He's missing George, so you'd be able to have a good chinwag about the stuff that you used to do. I bet you won't, Essie. What did you say you'd do, Essie? I forget now. Blue said
Didn't he say he was going to do an update?
I think you said you'd do a jig or something if he got his banjo out.
Did I say I would do a jig?
I don't know.
I didn't say, but I'll do a jig. What the hell? Why not?
Blue Marble says, I bet you won't, Essie. So I don't know what it was that you said you'd do. I can't remember.
Neither could I.
Did we get a pilot? Are we getting a pilot in? No. He's gone, has he? I guess it'd be tough. I wouldn't like to take this on. Defend a model. Right, so what have we got on? Still only early, isn't it? Right, let's I'm gonna put a Buster song on midway through. I need to go and make a brew. I'm gagging. So quick Buster song for you guys. I don't know. Do we start it off with Betty? Anybody got any requests? Come on. Let's hear a Buster request.
Rob is not here. He would make request, I think.
Yeah. What haven't we heard for a bit? Oh yeah, we've got a Rumpus one, haven't we? This is a pretty good one. Right, so you guys, you'll have to listen to the YouTube for a bit. I'll be back in a bit. The tangent being parallel to the surface.
Well, it is you do know what a tangent is, don't you?
Yeah.
To a circle.
Yep.
Good. Well, actually, I don't think you do. Actually, you've demonstrated many times you don't. But we'll go through it again. Hopefully, people know what a tangent to a circle looks like.
Yeah.
And therefore, that is at the point of contact. That the tangent and the horizontal are the same thing. So you could say they're both parallel to one another, but the horizontal and tangent are the same thing at a point on the Earth. If you change where you are on the Earth, you get a different tangent and a different horizontal.
What about the circle, though?
Is it a straight line, though?
Is the circle parallel to the tangent?
Is a circle parallel to the tangent? Well, a circle's is a curve. You've got to pick on a point. A tangent, that doesn't really make much sense. You can have a tangent to any point on the curve of a circle. At that point, the gradient or the slope of the curve of the circle, if you like, is the same as the tangent by definition. That's how a tangent is defined. It's the gradient of the curve at that one point where the line just touches a circle. That is a tangent.
Parallel?
And that parallel to what?
The surface. Parallel to the tangent.
Well, the tangent is defined. It's like, say, asking if something's parallel to itself.
What?
You don't understand what a tangent is, do you?
What he'll do, what the technique is they'll come in, they'll try to propose an answer to one of these unsolvable riddles, and then as soon as you try to object on some point of lunacy that they've made, they make it about, how you're so stupid and you don't understand. And then when anyone else tries to chime in to make it worse, is that you get a triggered flat earther that's like, how does this guy not see that, or whatever the fucking conversation is. And then they try to get in it. And then once now you've got two flat earthers against Rumpus, now he plays the victim.
Yeah.
And it's just, it's like, but this is what I'm saying, is like anyone who's still playing along with the charade, you're just airing out and giving them what they want.
You don't understand when I say gradient, you don't understand what I mean. You don't understand the basics. The fact you don't understand. I don't understand what kosher is. What I just said. You didn't understand what a gradient was, and the fact you don't understand this, that Bev doesn't understand the basics. So you don't understand what you don't understand what gradient means. But of course you. I don't understand what kosher's point is. Did you not understand what I said? I mean, my God, are you that stupid? You don't understand what I mean by gradient. So you don't understand what you don't understand what gradient means. Then. Really, this dense, you don't understand what I'm trying to do. You seem incapable of understanding simple things. You don't understand the basics. So you don't understand what you don't understand what gradient means. Then I think people understand what I mean by the gradient. It's going a slope. It's got a gradient of about 45 degrees here.
You don't understand.
But of course you don't understand this, so I don't. Right, so Armour understood exactly the point that I was making. You don't understand what a tangent is.
It's not my problem if you don't want to learn. You're just on your own.
Well, I've explained it in very basics, very precisely, very explicitly, and yet Bev will deliberately attempt to either misunderstand it or his IQ so low, he's incapable of understanding. I mean, don't understand what a tangent is, do you? I mean, you don't understand the basics. Claims to know about geometry. You don't understand the basics. They misunderstanding. You see, this is the problem with this guy. He doesn't understand what I'm trying. But Bev doesn't understand this because he's a moron. But you
I'm sorry, we're finished.
I can only do that if stand for basics, don't you? And clearly Bev doesn't understand it has a gradient. I think most of the panel understand what I mean by the gradient of the curve. You don't. I don't understand what Kosher's point is. The fact that you don't understand this is just unbelievable. And he didn't understand what a gradient was, did you? You then have to say, well, what's a gradient? I think most people understand what I'm saying if they're not trying to willfully misunderstand. I don't understand what Kosher's point is.
It's not my problem if you don't want to learn. You're just on your own.
Typical of you, when you're using everyday terms, apparently you don't understand what they mean. And I don't know whether you do this deliberately to misunderstand what you're being told, or whether you're just stupid. You don't understand the basics. A child of about 10 or 11 could understand. I don't understand what Kosher is. He's deliberately, willfully misunderstanding me, or he's really stupid. And you don't understand that at a tangent point, there is a gradient. You don't understand the basics. No, you don't, because there's a gradient at that point of a tangent. So you don't understand what a tangent is, do you? You don't. You're a moron. Because a point on a curve has a gradient. But don't you understand? It doesn't matter how much you zoom in. Well, because having to deal with people who seem to be willfully trying to misunderstand it. And if that's the case, I believe that's a disruptive behaviour. There's something that Ben doesn't understand, so everybody else tries.
You don't understand.
There's something that Ben doesn't understand, so everybody else tries.
You don't understand.
You don't understand what tangent is, do you?
It's not my problem if you don't want to learn. You're just on your own.
You don't understand what I mean by grade. You don't understand what a tangent is. The basics. Don't you understand?
No reason, no logic, no wisdom, no worry.
You don't understand what tangents are, basically, is what you're doing.
You're just on your own.
I don't understand what Kosher's point is.
No reason, no logic, no answers to questions. You're just on your own.
You don't understand geometry, do you? You don't understand simple geometry. You don't understand what a tangent is. I mean, you're incredible. Oh my God. Okay, you're too stupid. Anyway, I've got to go to bed. Bed's stupid, and well done, Armour. You understood. I don't understand what Kosher's point is.
No, I'm a Glober, yeah.
Yeah, exactly. So you understand geometry. Anyway, I'm off to bed. Well done.
And we're back. Sorry for that. Loads of people left. Obviously, hearing too much rumpus. You can't be listening to Buster. Okay, so we're back. I don't know really what we're doing. I wanted to go over some sort of logic, but I guess the planet one from Jerry. I don't know whether I really don't know. There's proofs and ways to gain proofs within all of this. They're obviously linked to mathematics and geometry. That's where all the proofs exist. The debate that I just had earlier, I don't know whether you could call it a debate. I don't think he had an argument. We try and go with proofs, and obviously it's the ECV. The entire thing about this is they claim certain things about verticals, but then, like Flat Earth Math said, it's impossible to measure it. You can't measure it. So you can't make claims about verticals if the same claim states it's impossible to measure it. You can't make a claim like that. It just doesn't work. So you have to then make another claim to state that if you can establish a horizontal, then you can have perpendiculars to that horizontal. Simple as that. If horizontals exist, then you can have perpendiculars to that. If you can have perpendiculars to a horizontal, if horizontal exists, then you can have two perpendiculars to the same horizontal and call them vertical. That's it. Two perpendiculars. Perpendiculars to a plane are all parallel. Can you do it? I state yes. We've done it. It's called the realizing Euclid test. It is a test to show that a straight line lies within the plane and that you can share the segment within that straight line and extend it. There was only two of us, but 3, 4, 5, 6, 7 people doesn't really make any difference. You would be able to keep doing this, extending the same straight line. But I say horizontal. I'm fine with my understanding of this. The point that comes in is when people state no. They say you can't have that, but I know I can because I've done it. I mean, spot on. We were out there. So, can you establish a horizontal in reality is the only question that needs to be answered. I state, yes, you can. I'm fine with that. And I'm going to keep saying this. Yes, you can establish a horizontal. And every time you do establish a horizontal, it will be parallel to the plane of the horizon, which makes all horizontals parallel to one another. That's a simple statement that's very easy for me to say because I know I can prove it. Have already proved it to myself. I can't actually prove it for anyone else, but I can give you the method and the ability to be able to do it for yourself. Only cost us £100. I know it's hard to get time to do that. But that's what we're here for. We do these sort of things. We go out there, do the tests. Other people can't do it. Well, we can. Got time to do it. We can go out and do all sorts of things. Actually, that's what I'm setting the channel up for. That's what we will be doing. Photography and these tests, geometric tests in reality. Some good fun times coming. And so if anybody else out there really wants to come in and have a conversation about any of these tests that you can do yourself, you just need somebody else, really. But I bet there's a way you could do it on your own. Basic principles could be done on your own. I want to know about the LIGO elevations. I want to know why some people would possibly believe that a horizontal has an elevation change on it. I can't understand why people would believe that.
They have to. The model dictates it must.
It's a ramp though, isn't it?
Yep.
Going from one elevation to another elevation along a straight path is a ramp. That's Mike. Is that what Mike's done? That's a good one, that. Ramping. You go, Blake.
Yeah, like a handicap ramp, you know?
Somebody's done a blue marble profile for you. Look at that. Is that who was that? I think Mike's done that. I think he's been on the he's been on the CAD, is it?
Mike's got some skills.
Yeah. Tangents. You put a couple of tangents there, that'd be all right.
Yeah, 2 arms right there. The facility in the middle. Damn.
That's nice. I'd like to see the other one. You. It's all right doing 2 slopes, 2 4-foot slopes. Easy peasy. That's sort of like child's play, that. It's everybody knows the Livingston, blue marble Livingston profile. That's the tricky one.
That's the special one.
Yeah, that's the challenge. Globe expert level. That's good, that mode, Mike. I like that. Bet we sound like a really weird group of people, don't we? When anybody's listening in, come into the Discord, because this isn't normal sort of stuff. Talking about the ridiculous antics that go on and how impossible it is. It's hard to say how impossible it is on the live, because we'd be giving away too many secrets. All of the proofs that we have. We tend to keep them to the Discord. But this is a little bit fun. I'm not too keen on the new sophistry, though, for the debate idea about definitions. Surely we should be able to understand what vertical and horizontal are without having to go through some definitional thing.
Yeah, this new sophistry, this sophistry 2.0, is something else to behold.
It's something to do with that. I think I'm going to have to go back over it's going to be a nightmare. Remember the Chaiki one, the perpendicular one with Chaiki? I think that was some sort of a tester for having an argument from nothing. I mean, how to deny Euclidean geometry and claim a win about not being able to teach somebody something. It's very strange. It left me confused as to what Chaiki was actually doing. But there must be some sort of purpose behind it, right? They can't just be mad, can they? You think that they do actually have some sort of a plan whilst being insane. There's got to be somebody back there that's got some sort of a plan.
The crazy genius in the background rubbing his hands. I have the plan. I envision Rumpus doing that.
Okay. Anybody got anything else we can go over? Do you want to? Should we go over your one, Etsy? We go over that with the elevation profiles?
If you like, yeah, sure.
Well, give us a. Have I got it?
You want me to post it?
I don't know whether I had it. Yeah. Yeah, I don't seem to have it anymore. Oh no, Blue Marble Science and I Taught LIGO. Yep, I've got it already, I see.
Okay, I posted it anyways, but okay.
Yeah, I posted it again anyway. Okay, right, we're going to go over this. We've got a little bit of time left. It's a bit early. I've got to get an early night. I've got to go out tomorrow. So, right. On there for you guys. This is... Do you want to set it up for us, Essie?
Well, this is a talk we're having over on Geos about LIGO. And, well, actually, this is about a picture. This is about a thing that Blue did, that Bev drew some stuff on the picture of the different heights and that. And I posted it, and I asked Blue to explain it. And, yeah, and a conversation ensued. Yeah.
Right, let me just get the... I'll put the
Concerning
image
LIGO.
in the live chat here, right? So it hasn't really got a big picture on the screen of it, has it? So I'll get the...
Yeah, that's the one that started the conversation. Yeah.
Okay.
That's a response to Bev from Blue.
Okay, now that's the video that we're talking about. So here we go. There's not much else to look at in the chat, is there? So if I leave that on that. So here we go.
SE. Can I talk to SE for a second?
Well, we can't just shut these guys down. Let's ask them politely first.
Shut it the fuck down. Go ahead, SC and Blue, go.
No. We're not going to shut you down, bro. Come on.
No, I'm going to bed. I'm pooped. I'm going to bed. So.
All right, later, Pazza. Go ahead, Blue. It's all yours.
Take it easy, fellas. Have fun.
All right. Good night, man.
Sorry, I thought I did ask politely.
You
No,
did.
you're
You
good.
did.
Go ahead,
I
Blue.
just wanted to make sure.
Go ahead. It's all you, Blue. Go ahead. Do it up.
So you wanted to say something about the LIGO, SE?
Yeah, that picture there. Let me put it up.
I got it up on my screen.
You got it? Post it in live chat.
You want me to post it?
If you don't mind.
Okay, hang on. That one, right?
You don't even call LIGO. What's it
Yeah,
sit
that's the
on?
one. Yeah.
If you can't have a vertical plane, you can't have a horizontal plane. What do y'all call them arms? What are they sitting on? How do you define them?
Can I get to SE's question?
Yeah.
No,
I just trying to ask a
let
question.
SC and Blue go through this LIGO thing.
What did you want to know, SE?
Yeah, like I was wondering. You got a 3 foot drop from one arm to the other, right? Or first of all, okay. Question number one: is LIGO on a plane?
It's two perfectly straight arms that lie in a plane. Yes.
Okay. So please explain the diagram. Because
Well,
what I see here, I see like a 1 foot drop that way.
This is LIGO Livingston.
Baby cakes.
That's the one we're looking at. That upper arm up there. And let's see, that would be the southeast. Which one is which? That would be the southwest arm, I guess. Yeah.
I don't know what's going on here. Look, it's not that hard to notice. He's got... Oh. My thing here was better. He's got the southwest arm here. And these are the elevation changes. 64, 63, 64.
Yep.
It's dead easy to notice this. This is his drawing. Blue seems a little bit slow.
How can you miss that? Yeah.
Why is it so hard for him to notice that? I don't know. I hope he's all right. Somebody make sure Blue's okay. It's not that hard. This was last night, right?
Yep.
Yeah. Somebody check up on Blue. Make sure he's all right. Rumpus, give him a call.
So the southwest.
The one at the
arm,
right angle.
Right.
Okay.
The southwest arm up there at the top, running left to right. Okay. Has end elevations of 64.12 feet and 64.09 feet. So the two end elevations of that arm are within 0.03 feet of each other. Okay. So if you just go on that basis, you would say that thing is virtually level. That's what you would call level, because the two.
That's what you call level. That's what you call level, because the two arms, two ends of each other, of these arms, this end here and this end over here, they're at the same elevation. He calls it level.
Yep.
Are you all right, Blue?
Two end elevations are the same, essentially. But the center elevation is not. The center elevation is 63 feet.
This is
Center elevation's not. This arm, Blue Marble has stated, you can call level because both of the ends are nearly level. But the center isn't. But you can call it level.
Nearly.
Sorry, Blue. I hope you're all right. Are you all right, Blue? Seems like you're struggling a little bit. You call it level, even though it drops down in the center. And it does actually drop down. It's got 1 foot down, and this one's 1 foot up to the center point. It goes down, back up again, and you call it level.
Where I was getting at. Yeah, how is that possible?
Well, because the Earth is curved. That's why. Because
concave?
That's what.
Yeah.
Maybe he is now concave Earth. I don't know.
Because the Earth's curved, it has a drop of 1 foot in the middle. Because the Earth's curved. But it's a straight line. It's a straight line.
On a plane?
On a plane, yeah. And we get to that, don't we? We put it on a plane at some point.
Yeah.
Yeah. Try your hardest, Blue. This is I said that's what you would. What? Oh, Blue. He was talking to me. He was talking to me when he said you could call that level. He was talking to me. It's nice for you thinking about me, but I was in bed, wasn't I? I wasn't even in there, Blue. Were you talking to SE? Because I don't think SE would call that level if it's got a 1 foot. Would you call that level, SE?
I don't think so.
No. Blue, I don't think that's fair for you to be saying what other people would call level. I wouldn't call level with a drop in the middle of a foot.
And we are not concave Earth.
No, I wouldn't.
Sorry.
Definitely wouldn't call that level. He was talking to SE, but SE said he wouldn't call that level, Blue. The only person that did call it level was you, Blue. It's you. It's recorded. You did actually say that. It wasn't SE that said it.
That's what has to happen.
Has to happen.
The arm, if it was touching, if it was tangent, it isn't though. Now let me make sure we understand something. That's not the tangent point, but let's say for a second that center point of that arm is tangent to a sphere with a radius of 3959 miles. Okay, then you're about 1.2 miles or so, 1.25 miles either side of center, and the drop over that distance is about 1 foot. Exactly what you see.
Well, hold on. Don't you have either end rising up from the tangent?
They're not rising up from the tangent, the elevation. The elevation of the arm
gets tricky, doesn't it?
Yeah, away from the tangent point. Yes.
On a plane?
That's a straight line.
It's a straight line. Right, SE, this is what you have to watch out for, right? Because Blue Marble Science is playing a trickery game, a bit like FE Math was the other day. And when Blue Marble said you could call that level, right? He was saying that to you, that you'd call that level. And the fact that you didn't notice that he was talking about you and you not disagreeing with Blue Marble talking about you means that you agreed with Blue, that you were the one that was calling that level. Isn't that right, Blue?
Now that's some Texas two-stepping right there, Blue.
That's Blue
Seriously?
Marble Science, yeah. Because you didn't disagree. He didn't object to it. Blue Marble's little trickery of him passing it on to you. The concave level.
Wow.
That's good, isn't it?
That's good stuff. Yeah.
That's typical Globe tactics, that, Blue. Yeah, exposing it all for us. Thanks a lot. I think you've been drinking, Blue, or been medicated, because you still sound a little bit slow. You're not as sharp as your usual self. I know that's not very sharp, but you can hear it.
That's some Harry Potter
Straight
trickery
line.
there. On a plane, and the center point is lower, and the two ends are higher.
Yeah. Imagine a ruler sitting on top of a ball, SE. The elevation.
A really big ball.
If you go out to the end of the ruler, down to the ball, that's the so-called drop.
Could be a tangent.
You've got to make that up.
A ball.
Yeah, but hold on there, Blue. Your ruler is bent upwards on either end.
No, it's
no longer.
No, it's not. It's not bent upwards, SE. It's perfectly
Well,
straight.
clearly there's a lower point in the middle and a higher on either end.
That's what happens with a spherical surface. You've got a perfectly straight line laying on top of a curved surface.
So that would make a straight line on a curved surface bend upwards on either end?
It's not bending, it's perfectly straight.
But clearly it's not. It's a foot. What is it? A foot lower
You're
in
talking
the middle?
about, that's elevation now.
He is, isn't he? He's conflating elevation with curvature.
Yeah. And he doesn't see that his ruler is no longer straight. It's unbelievable.
Got an elevation change of a straight line.
Yeah, on a plane. Oh no, this is on a ball, but nevertheless, it's a ruler. It's a straight thing, and he's got it higher at either end, lower in the middle. It's astonishing.
You've got to do some fantastic mathematics trickery to yourself for you to be able to accept that. I think.
Yeah, this is Harry Potter stuff. Yeah, yeah.
Sounds crazy, isn't it? The people I've tried to explain this to, they just get so confused about what it is you're trying to say. I mean, like explaining how an elevation change works. That's good. Right, here we go.
So you have a lower elevation in the center.
Yeah, the elevation in the center is lower than the elevation at the ends.
Hey, Blue Marble, you want to debate Troubling Tribune on the live stream, open panel, any Glovers or any Flat Earthers? He's going to have an open panel.
We're
So
doing it right here. We're doing it right here. Yeah, anybody can debate anyone right here. Let's do it.
Yeah, I know that, Jeremy.
You can go next. You can go next. Essy's right in the middle of this thing now.
How do we even join Troubling Tribunes when we're not here? How do we join?
I just posted a link.
This is actually recorded over on Earth Awakenings. I don't know who Tribble guy.
Just random weirdos.
Is that a new guy that's sort of be hot on the debate scene? Do I want to be debating him about something? That'd be good. I'm getting to be a debater. A traveling debater, talking to people. I'll have a word with him. But only over on Earth Awakenings. I don't know that other channel.
Yeah, I'm not trying to steal your people, Jeremy. I'm trying to see if anybody wants to do a live stream.
They are doing a live stream. SE's.
Oh, I thought you were trying to debate right here.
I will. I'll hang out. But I prefaced my statement. I was real specific about it. But, if you missed it, that's cool.
Yeah, I might have missed it.
So we're kind of in the middle of something here.
That's cool.
All right, SE. So the elevation in the center of the arm is 63 feet. But level drops away from horizontal. It drops away at a rate of 8 inches times distance in miles squared.
Okay.
So
your arms.
63 feet elevation there in the center is going to be way below that. It's going to be a foot below that horizontal, that arm by the time you get
Can you
to the
hear
end
that?
of it.
Yeah, it's going to be a foot below the horizontal arm. Like it is the elevation, isn't it? Of the arm.
It collapses. The arm collapses down in the middle.
Yeah.
It's high on the sides, but then it just kind of collapses in the middle.
But it'll be a foot away from it, though, he said.
Yeah.
I'll go back and just do it again, because this is...
It's like a V. It's like a V shape.
I think so. Like, it actually...
Exactly, yeah.
An elevation change of a foot is a slope down, and then a slope back up again. I mean, that's obviously... in reality what would happen, but Blue imagined something different. It's very strange. Listen to what he says.
Center is going to be way below that. It's going to be a foot below that horizontal, that arm by the time you get to the end of it.
It's going to be a foot below by the time you get to the end of it. What does that even mean? It's a troubled mind. I hope he's okay.
Amazing, isn't it?
Time space, maybe. I don't know.
Yeah.
The longer you travel, the better, the greater the drop is. I don't know why time matters here.
I know it might have been a bit since you made the video, Blue, but going
Haven't
over
heard
it
this.
seems, it's only last night. This
I haven't heard this, but I would love to make a prediction of what's to come.
Go on, please do.
Oh, SE, you don't have to answer this, but my prediction will be that Blue's gonna say that LIGO is your double drop and the hump at the same time.
You're not that. Yeah. Let's not spoil it. Yeah.
Okay. I think he does the opposite. To be honest, I don't know whether you can have the opposite, but I think so.
I think he does a bit of both, but yeah, he's all over the place.
Yeah, it's a plane, though, right? That's where you go next, I think.
Don't forget, I started off and it's a plane.
Yeah. You have to reiterate again in a minute.
Yeah.
Sitting on the ground, the elevation has to come up.
How so? I mean, I don't understand. Isn't your 8 inches per mile squared the other way? So how
No.
could your arms be going upwards, Blue? I
No,
mean,
no,
maybe it's me that's confused here.
Yeah, I think you're just. I wish I could draw a picture of this, but
Yeah, please, that would help if you can do that.
I wish I could.
None
I've
of
seen
them
it.
can draw a picture of it.
Many times.
Yeah, that's why Blue's going, I wish I could draw a picture of it, because I just can't. It's like, it's impossible. Nobody knows what it is that they're meant to be drawing a picture of. This is imaginometry. Blue's so lost.
This is why I said to Betty, and I'll say it again, there is no one who will draw this. No one will be able to 3D model this.
Especially with the twin tangents. But that was your drawing, right? You've already done your CAD for the LIGO ramp, the twin ramp LIGO. Uh-oh. That's pretty bad. Robius sounded like then. I don't know whether we should move to a different area for the server. Or are you out? Or maybe out. Play it for a little bit more. Hopefully, Mike, let us know if you come back, Mike. I'll pause it.
Just think about this. That elevation, that is that's like a level line. That's the curved line. Elevations are all curved. Okay.
So you're saying the arm
elevations are all curved. I don't know why you said that. Yeah, it's really weird.
Unbelievable. Arm is curved.
No, the arm's not curved. The arm is straight.
On a plane, like we established, right?
It's in a plane. It lies in a plane with the other arm, yes. But the elevation there at 63 feet at the center, that elevation it would be dropping away from that plane in both directions. And pretty much equally because the two end elevations are about the same. So as you go a mile and a quarter down the arm either way, 63-foot elevation is down below the plane by 1 foot. To get back up to the elevation of the plane, you've got to add a foot to it.
So you got to go up one way and down the other way on the arm. I mean, that's...
No, you're going up both ways.
Remember the arrows you had there?
Yeah.
Yeah.
I mean, did he not think you weren't going to ask about the other arm?
Yeah.
I mean, let's just talk about this one, not the other one, of course.
Oh, he's got a genius way of getting around that as well. I didn't even think about it myself.
Going up both ways.
The elevation has to come
from
up
the center.
on both ends.
From the center.
Yeah.
I just can't see it on a plane. You gotta. I don't know. Maybe I'm the one not seeing this, but to me, It just doesn't make any sense at all. And on the other side, you have a 3-foot drop. Explain the other side.
Actually, a 4-foot drop on the other side.
A 4-foot drop.
Yeah.
On the straightest thing supposedly in the universe. Isn't that how Vanek put it?
It's still straight, SE.
Still straight, but it has a drop.
There's a 4-foot change in elevation, but this is because of the point that they picked for that plane that the two arms lie in to be tangent to the ellipsoid.
See, they only picked one point on this one. Or
he changes it after. He puts it on the left arm in the center.
Yeah. He does. He keeps it, but there's only one tangent point to this one, not the twin tangents of Hanford.
No, this one he changes it. He doesn't keep them there. You'll see. You'll see after he changes it.
So how is the end of one arm 4 foot below the end of the other arm? This is hilarious. Yeah.
It's only 3 foot. It's only 3 foot below the center of the other arm.
Oh, well, how does that work?
It's 4 foot below the other two ends of the other arm.
How does the curvature work if one end goes up from the tangent and the other one goes down 3 foot? The one goes up a foot, the other goes. That's just wild. You got me at the edge of my seat.
Yeah.
Are you using that logic stuff again, aren't you?
I mean, maybe. I don't know.
The point of tangency is actually down toward the bottom of that picture and about midway of the upper arm. That's where the plane is actually tangent to the ellipsoid.
Hold on, you said the tangent was on the other arm.
No, see, I was doing that just to help you visualize what goes on.
So now, where did you place the tangent now?
The point of tangency for the tangent plane that the two arms lie in is down toward the bottom center of that picture.
The bottom center of that, where the numbers are?
Down below that.
Down below that is the point of tangency.
That's genius.
You hear that?
It was up here, right, in the middle of this arm, but now he's had to move it all the way down here, off like somewhere out of the way of the actual triangle altogether.
Completely away from it, yeah.
Do you know why?
Beats the heck out of me.
It's got 3 foot here at this end of this arm.
Oh, so he wants to put it at the highest or at the lowest?
The quadratic function would have 1 foot for this half of the arm and then 3 foot, right? It has to get bigger, doesn't it, as you get further away. Therefore, the tangent has to be over this side somewhere. Otherwise, this 1 foot, 3 foot wouldn't work. It has to be over here.
Right.
That's why he's suddenly moved it over here to this side, away from here. So, but it's got to be somewhere around here because this tangent point has to. So, over here, I'd hate to be a glober, right? But I mean, this is what they have to deal with. This is the elevation profiles of straight lines and planes that cause him massive problems. Uh-oh.
Guys never got together.
No, that's not working either. Sorry.
Okay.
Nearly. Let us know when you're back.
Now should be
no. It's not just me, is it?
No, it's not just
he's
me.
roboting, but yes, yeah. We cannot understand what.
Yeah, I can't.
It's too bad.
I
Mike
can't
is 20.
understand anything. Hopefully, you can come back, Mike.
For the tangent plane that the arms are in, yes.
Okay, well, so it would be like a triangle. You would draw another line and close the triangle type deal, and your tangency would be there in the middle of that that
No,
arm.
there's nothing there. It's the imaginary plane that the two arms lie in. That imaginary plane is tangent to a point down there toward the bottom.
Imaginary.
How is it an imaginary plane? He's got the arms of LIGO
Sitting
in it.
on
Like,
it.
yeah, I mean, how is it imaginary, Blue? The bit that you imagine where the tangent is, I bet that's imaginary. But the actual LIGO arms lying in that plane, that's real. So real, they've made some concrete slabs to put that on. Not imaginary, Blue. Only your dogmatic model. That's it. The rest of it's real.
Plane. Okay, I'm trying to envision this. Okay. So you got a 3-foot drop from one end to the other, but yet it's still in the center of the arm, of the right arm. It's still lower, and you still have elevation on either ends again.
Still have elevation on either end. Of course you do.
Okay, wow. This is something.
Okay, but what you then have to do, if you really want to see it, is you have to plot all of the elevations of both the arms. You got to plot each of the elevations, and then you see the curve.
You have to plot the elevation. You mean visually? If you how
No,
high?
you have to take the elevation data from the engineering drawings, from the as-builds, and plot that. Plot those elevations on a graph, and you'll.
I did hear Blue say the elevation the engineering drawings.
The as-built.
The as-builts, yeah. I wouldn't say they're the same.
No,
engineering drawings and as-built. They're not the same thing, Blue. But hey, you're the one that's doing the elevation profiles and stuff. We'll just go with what you say, right? But we have been talking to people about these as-builts.
You'll see the curvature.
Okay, so you're saying if we go down there and take readings and A, B, C, and some points in between, we should see different elevations along the arm.
You will.
Okay.
Blake,
And the
can you show me
3-foot
something
drop.
besides the as-built? Has it got to be the as-built? Like that's after the shit was built. Show me some plans with them numbers on them, please.
Them plans with them numbers on them are in that drawing package in the as-built. You can go back to Rev A.
Also use LiDAR data.
As-built are meaningless, bro.
Huh?
You can also use LiDAR data to show that it's the elevation profile is curved.
Yeah.
Oh, see, that's a new one.
Yep.
See, a new shadow giant enters the arena. LiDAR shows you a curved elevation.
LiDAR.
LiDAR, yeah. That's interesting. Very interesting.
Okay, let me ask another question, if I may, to Blue. So, Blue, we have basically a triangle here, a plane, and we have a 3-foot drop of one of the arms.
4 foot.
Sorry, a 4-foot drop on one of the arms.
It's just a 4-foot elevation change.
4-foot elevation change on one of the arms on the plane, which is lower in the middle, higher on either end. And on the other arm, we don't have this 3-foot drop.
No, wait,
which is also on the same plane.
Wait,
Oh.
back up.
Wait. Oh.
Okay.
When you started out talking, you started
much to
out,
process.
I thought
Yeah.
you were talking about the arm on the right, the more vertical one. You're talking now about the arm on the left to start with, and there is no 3 foot change in elevation, SE.
No, you were right. I was talking about the one on the right. And then I switched to the one on the left.
Okay, the one on the right starts at 64 feet and drops down to 60 feet.
Okay.
That's not 3 feet, that's 4 feet.
Okay, 4 feet. Right. So one of the arms has a 4 foot drop.
Okay.
This is now on a plane, of course. And the one on the left doesn't have this 3 foot drop, which is also on the same plane, but it has a lower point in the center of that arm.
Yep.
And also a foot elevation on the other, on either point.
Yep.
Wow. And all this is on a plane.
Huh?
Okay. Wow.
Say it again. You said all.
It does sound slow. I hate to say it. Blue, are you all right? Or was it just late at night? Had it been a hard day?
All this is on a what?
On a plane. This is, like we said,
On
this
a
whole
plane?
structure sits on a plane.
There isn't it. The two arms lie in an imaginary tangent plane. Yes.
An imaginary.
You hear that?
Yeah, an imaginary tangent plane. He imagines them as being in a tangent plane, but he knows it's imaginary. He knows the tangent plane he's talking about is imaginary.
Yes, and this is proof for globe.
Mm-hmm.
This imaginary tangent.
Yeah, the actual plane that the arms lie in, right, isn't imaginary. The only imaginary thing is the tangent plane. The imaginary tangent plane that Blue Marble's imagining. Actual plane exists. That's just a plane in reality, which probably is horizontal with 0 elevation change.
Not probably. Yeah. Unbelievable, Blue.
Yeah. Sounds slow.
Tangent plane?
There is no physical plane. You realize that, right?
Right, but I mean, we are talking about the straightest, levelest
Yeah.
thing that was ever built, right?
We're wondering why they even come up with the word plane, Blue. Like, we can't have a vertical plane, we can't have a horizontal plane.
Well,
So why even invent the word plane if we can't have it in real life? If it's just imaginary.
Well, I find it pretty handy, actually.
To imagine.
Or something.
I mean, it is that you do have a plane. You can have a plane not on a globe, but above it or below it or whatever, right?
Not a physical one, but you can
Well,
have.
there are no physical.
Okay, that's all I'm saying.
Yeah.
It's not a physical plane. There's nothing.
There are no
physical
physical.
there.
Oh my.
Yeah, there's no a plane's 2D. There's no 2D physical
Right.
things. Yeah.
Right. That's all I'm pointing out to SE. It's not a physical thing. The two arms lie in a tangent plane. That's an imaginary plane, obviously. They're all every.
Like, what's going on?
Yeah.
It's imaginary, yes. The tangent plane is completely imaginary, only because the tangent thing is imaginary.
Plane's imaginary. So maybe I'm being redundant. I don't know.
Just like the tangent in the imaginary bottom there. Imaginary
Right.
plane, you said.
Right. You can't have a vertical plane in real life, can you, Blue? I mean, not talking about the redundancy of the imaginary aspect of it. Just in real life, we can't have a plane that's vertical, right? Only a line, right?
Vertical plane sort of doesn't make sense to me, but
Right. And you can't have a
No, that was right.
horizontal
That was
plane.
right.
a vertical plane doesn't sound right to him.
Yeah.
Imagine that. Imagine reaching a certain age and hearing vertical plane and thinking, that doesn't sound right to me. And saying that out loud, right?
Yeah, I think Ruhif comes in here to correct him.
Yeah.
Right, Brian.
Thanks, man. Thanks.
I'll say yes, you can have a vertical plane the same way you can have a horizontal plane.
There you go.
Oh, there you
There
go.
it is.
Yeah.
Yeah.
Yeah, you can.
The altitude, like in the Altaz coordinate system, is the angle on the vertical plane.
All right. Debate Blue on it because Blue says it's. What'd you say about a vertical plane, Blue?
I said it sort of doesn't make sense to me in one way.
Don't make sense, Ruif. Your shit don't make
Oh,
sense, bro.
I know what Ruhif's saying. Yeah, I know what he's saying.
So spin that
So it doesn't make
vertical
sense.
plane on the azimuth until it lines up with your star or
Azimuth is
whatever,
the
and then the angle on that vertical plane is your altitude.
Right.
Doesn't make sense, Ruhif.
Okay, I think it does. I think Blue understands what I'm saying as well.
According to Blue, not me. According to Blue.
Well, maybe it makes sense.
I know
Then.
you
Does that
guys
make sense?
I know you guys love to pit globers against each other. Does
That's
Blue
my favorite
understand
part.
what I mean? Yeah, I know what he's doing. I'm aware.
I understand perfectly what Ruhif said.
It doesn't make any sense to him, a vertical plane, but he understands what Ruhif said.
Yep, he has
and
to
Ruhif
agree.
said there can be a vertical plane. But Blue doesn't understand it, but he does understand what Ruhif's saying when Ruhif says a vertical plane. But not when Brian says vertical plane. Doesn't understand that, but he understands it when Ruhif says it.
Yeah, this is where dialetheism comes in.
Yeah. That's when how you know that somebody's, let's say, bullshitting. Sophistry. But, I mean, I don't even know that Blue's aware of him doing sophistry. If he should know there that listening back to that and listening back to himself, just capitulating to whatever Ruhif said, even though Ruhif's just completely contradicted what Blue said. But Blue has to bow down to Ruhif. Oh, yes, I know what Ruhif's saying. Yes, that's right. It's obviously
Which makes me wrong.
Superiority, right? Yeah. Yeah, it makes you wrong.
Yeah.
Somebody's trying to pit Ruhif against Blue now. Even though they are contradicting each other. But, I mean, it's okay, because Blue understands Ruhif's contradiction. And Ruhif understands he's contradicting Blue.
Yeah. Simple. Yeah.
That's Globe. His Globe.
His Globe.
Said that you can't have a vertical plane.
You cannot.
So we can have a vertical plane.
Yeah.
Yeah.
Okay.
Didn't make sense to him. It didn't make sense to him. But then since Ruhif said you can, he went, oh, well, I understand it now. And yes, you can have a vertical plane. I do understand it. Well done, Blue. Quite clear to see who the superiors are. I think that's the end of it. Yeah, that's it. The saga of the elevation profiles of the LIGO straight arms will continue. Wait till you start seeing the curved upwards elevation profiles that we have. They look very globe-like. Where's SC? Oh, it's Dark Otter. Is he posting them? There you go. Look at that. Predicted it. Upward curving horizontals. If anybody needs to come into Discord to see what's going on. These are the LIGO elevation profiles done by Stark Otter. He's proud of them. He's proud of them.
Wow. They really drank from the sauce.
Yeah. We've got a guy in the chat there. He's got an Earth curvature. He's got a curvature calculation that's different. SE said a vertical plane sort of doesn't make sense, but it did make sense when Ruhif told him it made sense.
Yeah.
You know,
Yeah.
it sort of didn't make sense until Ruhif told him that it did make sense.
Then it made sense.
Yeah. Ruhif made sense of stuff that you couldn't make sense of by saying that it did make sense. And you went, oh, okay then.
That's a
Oracle
magic
has
power
spoken.
Ruhif has
Yeah.
over Blue.
Superiority, obviously, within the... I bet Ruhif's about 34 or 35 or something. Blue must only be a bit lower.
Past 33. Holy moly.
Oh, look, Starcotter, he's done another one. Elevation profile. What? That blue first line is straight for 4,000 feet. Then it starts to go down. But the rate changes, which it means it is indeed a curve. You
Straight
can tell
for
because the segments on the blue line gets longer. The graph basically has the shape of a spoon. Since you didn't explain what? What's he talking about? It's Hanford. It's getting weirder, I'm telling you. Look at it.
I never heard nonsense like that.
Starcoder, what are you doing?
Some kind of desperation, maybe. I don't know.
Why has he got two different... Is he saying that the GPS is like fucking miles out or something? What? The actual elevation profile. So this is an elevation profile that changes half a foot. What? Elevation profile, GPS. What's the difference? Like, I don't even understand. I mean, it's crazy. Maybe some construction guys do it. It's got something to do with Tis Globe, right? They're meant to be straight lines. That red line isn't a straight line. I don't know. Is he Starcotter? Is he talking about the surveyor's lion that did the as-built? You do realise that the surveyors didn't do the as-built, right, Stark? Surveyors don't do the as-built. Unless they did employ surveyors to do it. And if they employed surveyors to do it, whoo, did they mess up? I don't know. I really don't know what's going on. This
You just can't see it.
Madness.
You just can't see reality for some reason. They just can't see it.
Does anybody know who Starcotter is? Does anyone? Yeah, no?
I have no idea.
No. I haven't got a clue. Nobody knows who he is. Nobody knows what he's doing. Yet, he seems to be throwing a spanner in the works for Blue Marble Science. Earth, if you want to come in, come and have a chat. You'll not get very far in the YouTube text chat. We don't tend to YouTube text chat debate while we're doing our live shows, and unfortunately the people in the text chat they're not up for debating. Debating gets done in the Discord. The text chat, obviously that's people who just listen. Don't think you'll get much debating in there, to be honest. Yeah, it's a bit hard to get rid of 90-degree angles, right? Right angles. They're called right angles because they're right. 4 of them, they're all the same. And there's no room for any more. Only 4. Because there are no lines, the lines with 1 dimension and planes with 2 dimensions, they don't really exist, so you're living in the mathematical realm. There literally is no more space than the 4 right angles that make up the entire full circle, if you call it. It's hard to know what to call it without calling it a circle, isn't it? It's just 4 right angles exist within space, and you can relate those two in planes in 3 different axes. So again, I don't know what you're talking about, but I'm with Horizontal Wanderer. Yes, in reality there are right angles. We use them for construction purposes. Close the stream down. Again, have we got Rob back? No, Rob's still out. I'm gonna end it tonight. Tomorrow is Wednesday. It's Trivium Day. Hopefully, I'm hoping that we can start really going back over the lost tools of learning. It's going to be needed more than ever, I think, in the coming times. There's a lot of hard times coming for people, and it's gonna aid us if we can have a firm footing and an understanding. For me, mainly, I can see a lot of people going mad, and I'd like to make it before everybody does go mad and start attacking each other or whatever, just because madness sets in. I'm hoping that there are going to be a few people that can actually come and have communication to communicate, rather than the ChatGPT bots that text chats. It's going to become a lot more vocal. We need people to be vocal and actually talk. So come on into the Discord. We're going to try, hopefully if we can, go over the lost tools of learning again, to let people know, how important this sort of stuff is, mainly to keep your mind active, and not lose it to this contradictions and paradoxes that they're all setting up for each other. Certain people aren't good for their friends' minds. If you've got people that are going to help you accept contradictions, paralogize for you, they're not real friends. Come into the Discord and do whatever. Anybody want to give us a Buster song for otherwise I'm looking now.
See, if you give me about 5 minutes, I could do a sneak peek.
Something new.
Oh, yes. Well, we can do that. We can waffle for 5 minutes for a fresh Buster live
Indeed.
performance. Yes, we can do that.
Just sorry, I was not prepared for. I thought
No rush.
I could dedicate this to SC today.
There's no rush. We can waffle for a fair bit.
Okay.
If that's what you need.
Yeah, just like.
But get everybody in. Buster's going to do a live performance. This is when you should be sending out for your friends. Come on, get them in. Live Buster. World famous Buster live in a couple of minutes. And if you want to come in and listen to it live, then come into Discord now. You get better sound quality, I think.
Through Discord, it's pretty good. Like, it's always better if I was streaming like straight to YouTube, but this should work.
Jairo's got the good memes. Imagine trying to bend the plane, you know? Make things do like crazy things on a plane.
Having to,
yeah. Having to. Yeah. Yeah, I like that one.
Yeah, we know how many people we've got watching Blue. We know. Thanks for reporting for us, though. Next time.
Are you showing off again, Blue?
Blue doesn't like it. Blue will have gone. He doesn't like listening to Buster.
The truth hurts.
It doesn't like the music. He likes more. What I don't know. What was it? The banjo music.
Yeah. I actually like that. I actually like banjo music, to be honest with you.
Check out Bela Fleck if you like banjo.
Who?
Bela Fleck.
Okay.
He's like a jazz fusion banjoist, which is super.
Jazz. Yeah, gotta hear that.
Yeah. If you don't like it, then something's wrong. Okay, let me pull this up. This is semi-recorded, mostly live though. Is that coming through?
Yeah. Loud and clear for me.
All right. Hopefully I don't botch this up. But if it is, it's all right. It's live. It's no big deal.
Yeah.
Here. Oh, hope I could probably practice it, but oh well. Hey, this is on the fly. I'm a little nervous. Are y'all ready?
Yeah, we're all good. I'll end it after this. So thank you very much. Join us tomorrow. Buster's going to sing us out. World famous Buster.
Hell yeah.
Change one thing. Sorry for the pause. Here we go. I see the writing on the wall, it's plain. Ramblings of these madmen going insane. And now I see it clear. They're running and they're hiding because of fear. If I don't sing, if I don't speak out, if I never communicate with logical will, if I don't sing and if I don't speak out, if I never receive the Logos, who will? Transcendental numbers, conceptual maths will take you on a journey down a Penrose path, and you'll never see it clear. The path that you're on only ends in tears. If I don't sing and if I don't speak out, if I never communicate with logical will, if I don't sing and if I don't speak out, if I never receive the Logos, I'm taking back everything that was lost. I'll take it back at any cost. I'm taking back everything that was lost. I'll take it back at any cost. If I don't sing and if I don't speak out, if I never communicate with logical will, if I don't sing and if I don't speak out, if I never receive the Logos, we'll cast away the shadows and step into light. We're taking down the giants and opening sight. And now I see it clear. They're running and they're hiding because of fear. If I don't sing and if I don't speak out, if I never communicate with logical will, if I don't sing and if I never speak out, if I never receive the Logos, who will? Who will?
Famous Buster, new track coming.